Now in this video we'll discuss another very important fundamental in case of a parabola, and which is equation of a normal. So suppose we have a parabola y square equals 4ax. Now from any point on this parabola, say which is at square twice at, a normal is drawn. We have to find equation of this normal. Now we know that for any point P lying on parabola at square twice at, slope of tangent is given by 1 upon t. Now if slope of tangent is 1 upon t, then we can write slope of normal, it will be minus t. So at any point P on this parabola, slope of normal is defined as minus t. Now we have slope, we also have this point. We can write this equation as y minus y1, which is y minus twice at equals minus t, and then x minus at square. So we can write this equation as y plus tx equals at cube plus 2at. So equation of any normal to parabola y square equals 4ax will be of the form y plus tx equals at cube plus 2at, where t is the parameter of the point from which this normal is drawn. Now we can also write this equation in terms of slope. So we know that t equals minus m, where m is slope of normal. So we'll replace t with minus m. We can write this equation as y equals mx minus am cube minus 2am. So equation of normal to a parabola in terms of slope of normal is y equals mx minus am cube minus 2am, and in terms of parameter t, it is y plus tx equals at cube plus 2at. So this is the equation of normal for the first form, which is y square equals 4ax. If we have this parameter t, we can write this point from which normal is drawn, and we can also write its equation. If we have slope of normal also, then too we can write equation of normal to this parabola, and we can also write this point of contact, which we actually call foot of normal. So this point P, which is foot of normal, this t is minus m. So this point is at square 2at. So we can write this point as am square minus 2am. So if slope of a normal is m, then the point from which this normal is drawn is given by am square minus 2am, and this point P, it lies on this given parabola, which is y square equals 4ax. So now we can start writing the results. So if the equation is y square equals 4ax, we can write equation of normal as y plus tx equals at cube plus 2at, or y equals mx minus am cube minus 2am. Now if the equation is of the second form, which is y square equals minus 4ax, then all we need to do is replace a with minus a. In that case, equation of tangent will be y plus tx equals minus at cube minus 2at, or y equals mx plus am cube plus 2am. Now we'll come to this third equation of parabola, and that is x square equals 4ay. Now we know that for this parabola, any point on this parabola, we can write this as 2at comma at square. Now if we'll differentiate this, we'll get 2x dx upon dy and this is 4a. So we can write slope of normal at this point P as minus dx upon dy at this point P, and it'll be minus 2a upon x, and x here is 280. So it'll simply be minus 1 upon t. So now we have this slope and we also have this point. So we can write this equation as y minus y1, y minus at square, and this is minus 1 upon t, and x minus 280. So we can write this equation as ty minus at cube minus x plus 280. So we can write this equation as x plus ty, and this is at cube plus 280, which is nearly same as this first equation. So if in the first form, if we interchange x and y, we get this third form, and if in the equation of normal to this first form, if we interchange x and y, we get equation of normal for this third form, which is x plus ty equals at cube plus 280. Now we also know equation of normal in terms of slope for the first form. So if for the first form, again we interchange x and y, we can write this as x equals, and I'll take this as some m dash y. So m dash y minus a m dash cube minus 2a m dash. Then we can write this as m dash y equals x plus a m dash cube plus 2a m dash. So we'll divide with m dash, we'll write y equals 1 upon m dash x plus a m dash square plus 2a. Now 1 upon m dash is slope of this normal. So let slope of this normal is m. So we can write this equation as y equals mx plus a upon m square plus 2a. So in terms of slope, its equation will be y equals mx plus a upon m square plus 2a. Now we can verify this from this equation also. We know that slope of normal is minus 1 upon t. So we'll put t as minus 1 by m. We can write this equation as x minus 1 by m y, and this is minus a by m cube minus 2a by m. Now we'll multiply it with m. So we'll write mx minus y minus a upon m square minus 2a. Now we'll rearrange. We can write this as y equals mx plus a by m square plus 2a, which is same as this equation. So that means equation of normal for this third form will be x plus ty equals at cube plus 280 in terms of parameter t, and will be y equals mx plus a upon m square plus 2a in terms of slope of a normal. Now in the same way, we can write result for this fourth form, which is x square equals minus 4ay. So it will be x plus ty, and then we'll write this as minus at cube minus 280, and here it will be y equals mx minus a upon m square and then minus 2a. So this is how we can write equation of normal for all the four forms of parabola. Now suppose we are not given parabola in the standard form, but we are given a parabola whose axes are parallel to coordinate axis. Say for example, suppose we have this parabola which is y minus k whole square equals 4a x minus h. So for this parabola, what we'll do is we'll compare it with the standard parabola, which is capital Y square equals 4a capital X. Now for this parabola, we know that equation of normal, it will be capital Y equals m capital X minus am cube minus 2am. Now in place of y, we'll write y minus k, and in place of x, we'll write x minus h. So we'll write this equation as y minus k equals m x minus h minus am cube minus 2am. So from these general equations, we can write equation of tangent and normal to parabolas whose axes are parallel to x-axis or y-axis. So let us take up an example. Say for example, suppose we need to find equation of normal to parabola y square equals 8 x plus 2 whose slope is say 3 units. Now we'll compare it with the standard equation. We can write capital Y square equals 4a capital X. Now here a is 2, capital Y is equal to small y, and capital X is x plus 2 and the value of m is 3. So we can write equation of normal as capital Y equals m capital X minus am cube minus 2am. Now capital Y is simply y, so this is y. What is the value of m? M is 3, so it will be 3, and then in place of x we'll write x plus 2 and then minus a is 2, so it will be 2m cube, so it will be 2 into 3 cube and minus 2a, so there will be 4 into 3. So we can write this equation as y equals 3x plus 6 and it will be 54 minus 12, so it should be y equals 3x minus 60. So equation of normal to this parabola y square equals 8x plus 2 whose slope is 3 is y equals 3x minus 60. Now let us consider some questions on normal of a parabola. Now it says if x plus y equals k is normal to y square equals 12x, then find the value of k. Now we know that for this line slope is minus 1, and for this parabola y square equals 4ax, value of a is simply 3. So equation of normal is y equals mx minus am cube minus 2am. So we can write this equation as y equals, now m is minus 1, so it will be minus x and then m cube, so it will be minus minus plus, and then a, it is 3 and then plus 6. So we can write this equation as x plus y equals 9. So that means value of k is simply 9, and that's your option number B. Now here the question is, let L be a normal to parabola y square equals 4x, and if L passes through the point 9, 6, then L is given by which of the following equations. So now for this parabola we know value of a is simply 1. So we can write equation of normal as y equals mx minus am cube and minus 2am. Now we need the normal which passes through the point 9, 6. So we'll put this value. So 6 equals 9m minus m cube minus 2m. So we can write this equation as m cube minus 7m and then plus 6 equals to 0. So we can write this equation as m cube minus m and then minus 6 m minus 1. So we'll get this equation as m, and then here will be m square minus 1, so it will be a plus b a minus b. So m plus 1 m minus 1 minus 6 m minus 1 equals to 0. So we'll take m minus 1 common, then we can write m square plus m minus 6 equals to 0. So it will be m minus 1 and then m minus 2, m plus 3 equals to 0. So that means we get 3 values of m. M is 1 or 2 or m is minus 3. So from this point 3 normals can be drawn. So now there will be 3 normals that can be drawn from this point 9, 6. So we'll take m as 1, then we'll get this equation as y equals x and then minus 3. So then the equation will be y minus x plus 3 equals to 0, and that's your option number A. Now if we'll take m as 2, we'll write this equation as y equals 2x minus 8 minus 4. So in that case equation will be y minus 2x plus 12 equals to 0, and that's your option number D. So if the value of m is minus 3, in that case we'll write this equation as y equals minus 3x and then minus m cube. So it'll be plus 27 and then plus 6. So we can write this equation as y plus 3x minus 33 equals to 0, and that's your option number B. So answer to this question is option A, B and D. So now we know that for this parabola, which is y square equals 4ax, equation of normal is y equals mx minus am cube minus 2am. Now suppose we need to find equation of a normal which passes through a point, say alpha comma beta. So that means this normal will pass through this point. So we can write this as beta equals m alpha minus am cube minus 2am. Now we can rearrange this equation and we can express it as a polynomial in terms of m. So we can write this equation as am cube plus 2a minus alpha m and then plus beta equals to 0, which is a cubic equation in m. So that simply means from a point, if we draw a normal to a parabola, so then we get a cubic equation in m. And if we have cubic equation, we have two possibilities. Either it will have one real root or it will have three real roots. So that means from any point, either one normal can be drawn or from a point, three normals can be drawn to a parabola. So there'll be many questions where we'll be using this cubic equation to find relationship between slopes of three normals that can be drawn from a point to a given parabola. So suppose we have this parabola which is y square equals 4ax. Then from certain points we can draw three normals to this parabola whose slopes are m1, m2 and m3. Let us consider a question where from this point alpha comma beta, three normals can be drawn. So if three normals can be drawn from this point P, alpha comma beta, we know that its cubic equation will be am cube plus 2a minus alpha m and then plus beta equals to 0. And this equation will have three real roots which are m1, m2 and m3. Now if we write sum of roots, which is m1 plus m2 plus m3, now in this case m1 plus m2 plus m3, so there is no m square, so it will be simply 0. So if from a point three normals are drawn to a parabola, then sum of slopes of these normals should be 0. Now we can write this result in other terms also. So we know that if we draw a normal to a parabola whose slope is m1, then this foot of normal, so say in this case it is a, so it will be a m1 square twice a m1. This point is say b, which is a m2 square twice a m2, and c, which is a m3 square twice a m3. Then if we'll find the sum of their y coordinates, so y1, y2 and y3, in that case y1 plus y2 plus y3, we'll take 2a common and then it'll be m1 plus m2 plus m3. So we know that m1 plus m2 plus m3 is 0. So from here we'll get this result, which is summation yi equals to 0, which simply means if these 3 points are foot of normal drawn from a point on a parabola, then sum of their y coordinates, it must be 0. And these 3 points A, B and C, which is foot of normal drawn from point P, are called as co-normal points. So for co-normal points, y1 plus y2 plus y3 must be 0 and m1 plus m2 plus m3 must also be 0. So this is the condition for co-normal points on a parabola. So co-normal points are those points on parabola at which normals drawn will be concurrent at a point. We draw a normal at A, B and C all the three normals, they'll intersect at this point P. So these 3 points A, B and C, they are co-normal points. Now here we need to prove that circle through co-normal points passes through vertex of parabola, and we need to find its equation also. So suppose there is a point P which is say x1, y1, and from this point 3 normals are drawn to the parabola. So we know that equation of normal to parabola is y equals mx minus am cube minus 2am. Now this normal, it passes through this point x1, y1. So we can write this as y1 equals mx1 minus am cube minus 2am. Now we can write this equation as a cubic equation in terms of m. So we can write it as am cube and then plus 2a minus x1 into m and plus y1 equals to 0. Since 3 normals can be drawn, so we know that this equation will have 3 roots, m1, m2 and m3, and we also know that m1 plus m2 plus m3 is equal to 0. Now we know that if the slopes of normal are m1, m2 and m3, then in that case foot of normal will be given by am square minus 2am1, b am2 square minus 2am2, and c am3 square minus 2am3. Now we need to find equation of a circle which passes through these 3 co-normal points. So let us take any general equation of circle. So a circle which passes through these 3 co-normal points, let it be x square plus y square plus 2gx plus 2fy and then plus c equals to 0. Now all these 3 points, they lie on this circle, and if we write general condition or general coordinates for these 3 points, we can write it as am square minus 2am. Now we'll put the value of x and y in this equation. We can write this equation as a square m to the power 4 plus 4a square m square plus 2g am square and then minus 4f am and plus c equals to 0. So we can write this as a 4th degree equation in m. So we can write it as a square m to the power 4 plus, now here it will be 4a square plus 2ag m square minus 4f am and then plus c equals to 0. Now this 4th degree equation will have 4 roots. So say m1, m2, m3 and m4. Now we'll find sum of roots m1 plus m2 plus m3 plus m4. Now there is no m cube here, so that means sum of all the roots is 0, and we know that m1, m2 and m3 are slopes of normals which are drawn from the same point. Then m1 plus m2 plus m3 is 0. So we'll put this as 0. We'll get m4 as 0. If we'll put m4 as 0, then we'll get one of the point from which this circle will pass. So this circle will pass through 0, 0 and which is vertex of this parabola. So that's our first part, that the circle through co-normal points passes through vertex. Now we need to find its equation also. So what we'll do is we'll put 0, 0, then we'll get the c as 0. So we'll put c as 0 and then I'll take a common and also I'll take m common. So if I'll take am common, then I can write this equation as am cube plus 4a plus 2gm minus 4f equals to 0. So we get this cubic equation whose roots are m1, m2 and m3. which again is represented by this equation. So we'll compare these two equations, then simply we can write 2a minus x1 must be equal to 4a plus 2g, and in the same way we can write y1 must be equals to minus 4f. So here we can get the value of g. So value of g here will be minus x1 plus 2a divided by 2, and f will be minus y1 by 4. So now we have g, f and c. So now we can write equation of this circle. So equation of this circle will be x square plus y square plus 2gx. So it will be minus x1 plus 2ax and then plus 2fy. So which will be minus y1 upon 2, y equals to 0, and that is the equation of circle passing through three conormal points. Now the question is, normals are drawn from point P with slopes m1, m2 and m3 to parabola y square equals 4x. If locus of P with m1 into m2 equals alpha is a part of parabola itself, then find the value of alpha. We need to find locus of this point P. So suppose we let this point P as some h comma k, and for this parabola we'll know value of a is 1. So we can write equation of normal as y equals mx minus am cube minus 2am, a is 1, so it will be minus 2m. Now this normal, it passes through this point h comma k. So it will be k mh minus m cube minus 2m. So we'll write this equation as m cube plus 2 minus hm and then plus k equals to 0. So which is a cubic equation in m. Now we know that for this equation m1 into m2 into m3, its value is minus b upon n. So it will simply be minus k. Now it is given that m1 into m2 is alpha. So we'll put m1 into m2 as alpha. We can write m3 as minus k upon alpha. Now m3, it is the root of this equation. So we'll put the value of m3. We can write this as k cube upon alpha cube, and then this minus sign, and then minus 2 minus h k upon alpha, and then plus k equals to 0. So we can take this k common, and then we can write this as k square upon alpha cube plus 2 minus h upon alpha, and then plus 1 equals to 0. So we can write this equation as k square upon alpha cube, and it will be h minus alpha minus 2 upon alpha. So we'll write this equation as k square equals alpha square h minus alpha minus 2. So locus of this point P, it will be y square equals alpha square x minus alpha plus 2. Now in the question it says the locus of this point P is a part of the parabola itself. So that means this locus, it should be y square equals 4x. Now we'll compare, then we'll get two conditions, and which are value of alpha square should be 4 and alpha plus 2 should be 0. So from here we'll get only one condition, and that is alpha equals minus 2. So answer to this question is the value of alpha should be minus 2. Now here the question is, normals are drawn from point 4, 1 to the parabola y square equals 4x. The tangent at the feet of normal to parabola y square equals to 4x form a triangle ABC. So first we'll find equation of normal. So for this parabola, value of a is 1. So we'll write equation of normal in parametric form. So equation of normal in parametric form will be y plus tx equals at cube, and a here is 1, plus 280. So there'll be simply 2t, and we need normals passing through 4, 1. So we'll put x as 4 and y as 1. So it'll be 1 plus 4t, and this is t cube plus 2t. So it'll be t cube minus 2t minus 1 equals to 0. Now we can add 1 and subtract 1. So we can write this as t cube plus 1. So it will be t plus 1, and then t square minus t plus 1, and then minus 2, and it will be t plus 1. So we can write this as t plus 1 and t square minus t minus 1 equals to 0. So value of t is minus 1, or the value of t is 1 plus minus under root 5 upon 2. So now we have t1, t2 and t3. Suppose t1 is minus 1, t2 is 1 plus under root 5 upon 2, and t3 is 1 minus under root 5 upon 2. Now we know that these point of intersection of tangents is a t1 t2 and a t1 plus t2. So we'll write these point of intersections as, suppose a is t1 t2. t1 t2 is minus 1 minus root 5 by 2, and then t1 plus t2. So we'll add them. We'll get minus 1 plus under root 5 by 2. Now b will be t2 t3, 1 minus 5 minus 4 upon 4 will be minus 1, and then t1 plus t2. So it will be minus 1 comma 1, and c will be t1 t3. So it will be minus 1 plus root 5 upon 2, and then t1 plus t3. So it will be minus 1 minus under root 5 by 2. Now first we'll find centroid of this triangle. So centroid of this triangle will be, now we'll add the x coordinates. So it will be root 5 by 2 will cancel. So we'll get minus 1 and then minus 1. So it will be minus 2 by 3, and its y coordinate, it will be, now root 5 by 2 will cancel. So it will be 0. So distance of focus from centroid. So we know that for this triangle, focus is at a comma 0. So it will be at 1 comma 0. So distance of focus from centroid, it will simply be mod of 1 plus 2 by 3. So it will be 5 by 3. So option A, it matches to 5 by 3. Now the second question is distance of focus of this parabola from orthocenter of triangle ABC. Now we look at this T2 and T3. Then if we will multiply T2 into T3, we know that this value will be minus 1. When T2 into T3 is minus 1, so it simply means that these two tangents, they are perpendicular. So this triangle ABC will be a right angle triangle, and point of intersection of T2 and T3 is B, which is minus 1 comma 1. So that means orthocenter of this triangle is at minus 1 comma 1. So distance of focus from orthocenter, so it will be simply BS, and will be under root of, now this is 2 square and then plus 1 square, so it will be simply root 5. So distance of focus from orthocenter of triangle ABC is simply root 5. That's your option number D. Now the third question is distance of focus of parabola from circumcenter of triangle ABC. Now since this triangle ABC, it's a right angle triangle, then its circumcenter is actually midpoint of hypotenuse. So let circumcenter be some C dash. So C dash is midpoint of AC. Now what's A? A is minus 1 minus root 5 by 2, and C is minus 1 plus root 5 by 2. So we'll find its midpoint. So root 5 by 2 will cancel. So it will be minus 1. So it will be minus 1 by 2. So again for y coordinate, root 5 by 2 will cancel. So again it will be minus 1 by 2. So distance of circumcenter from focus will be under root of, now 1 minus 1 by 2 will be 3 by 2. So 3 by 2 square is 9 by 4 plus 1 by 4. So it should be under root of 10 by 4, which is simply root 5 by 2, or under root 10 by 2. And that's your option Q. And now this last one, which is area of triangle ABC. Now area of triangle formed by tangents. is given by 1 upon 2 a square, and then it is t1 minus t2, t2 minus t3, and then t3 minus t1, its modulus value. So it will be 1 by 2. Now a in this case is simply 1. Now here t1 is minus 1, t2 is 1 plus root 5 by 2, and t3 is 1 minus under root 5 by 2. Now what's t1 minus t2? t1 minus t2 will be minus 3 minus root 5 by 2, and then t2 minus t3. t2 minus t3 will be simply root 5, and then t3 minus t1. So it will be 3 minus root 5 by 2 and its absolute value. So it will be 1 by 8 and then root 5, and this is a plus b, a minus b. So there will be 9 minus 5. So it should be 4. So its area should be root 5 by 2. So area of triangle ABC is under root 5 by 2, and that's your option S. So this is how we can solve this question. If we have any parabola, say y square equals 4ax, and if we draw a normal at any point P, suppose this P is at square 280 or at1 square 281. So we draw a normal at P which intersects this parabola again at point Q, which is at2 square twice at2. Then this chord PQ is called as normal chord of this parabola. So that means we are drawing a normal at this point P which intersects this parabola again at this point Q. Now if PQ is a normal chord of this parabola, then we know that slope of any chord of parabola is 2 upon t1 plus t2. Now since this line, it is normal at P, and we know that at any point slope of normal is simply minus t, and which in this case is minus t1. So we can write this as t1 plus t2 is equal to minus 2 upon t1, or we can write t2 as minus t1 and then minus 2 upon t1. So that is the condition for normal chord. Now there are many questions on normal chord of parabola. One of the question is, there are 3 points. Suppose we have 2 points P and Q, and it says normal drawn at P and normal drawn at Q, they intersect on parabola. Then we need to find relation between their parameters. Suppose P is at1 square twice at1 and Q is at2 square twice at2, and suppose this is point R, which is at3 square twice at3. Now since PR is a normal chord, we know that T3 will be equal to minus T1 and minus 2 upon T1. Now this QR, it is also a normal chord. So again we can write T3 and it should be equals to minus T2 and minus 2 upon T2. Now what we'll do is we'll eliminate this T3. So we'll eliminate this T3. We can write minus T1 minus 2 upon T1, and it should be equals to minus T2 minus 2 upon T2. So now we'll take this T2 on the left hand side and minus 2 upon T2 on the right hand side. We can write T2 minus T1, and this is 2 upon T1 minus 2 upon T2. So we can write this as T2 minus T1, and this is 2, and again it is T2 minus T1 upon T1 T2. So one result that we'll get from here is T2 equals T1, but it is not possible because in that case these 2 points P and Q, they'll be same point, they won't be distinct points. So we'll discard this condition. So the condition that we'll get from here is the value of T1 into T2, it should be equals to 2. Now here we need to find length of the normal chord. Now suppose this PQ is normal chord, which means we have drawn a normal at this point P which intersects this parabola again at this point Q. So we already know that relationship between T1 and T2 is minus T1 and minus 2 upon T1. We know that length of any chord of a parabola is a, and then mod of t2 minus t1 and under root of t1 plus t2 whole square and then plus 4. Now what we'll do is we'll replace this value of t2. So we'll write everything in terms of t1. So we can write this length L as a, and then we'll write minus t1 minus 2 upon t1 minus t1, and here it will be t1 plus t2. So it will be 4 upon t1 square and then plus 4. So we can write this length as L, and this is a, and here it will be 2t1 plus 2 upon t1. So we'll take this 2 common. It will be t1 plus 1 upon t1, and here again we'll take this 2 common and it will be under root of 1 upon t1 square plus 1. Now we can write this equation as y equals 4a, and this is t1 square plus 1 upon t1, and here we can write this as t1 square plus 1 to the power 1 by 2 upon t1. So length of normal chord drawn at any point t1 will be t1 square plus 1 to the power 3 by 2 upon t1 square. So that is the formula for length of normal chord of parabola. We can write this as, now here the question is, find the locus of middle point of normal chords of this parabola. Y square equals 4ax. So we have this parabola y square equals 4ax, and then we have this normal chord, normal at P intersects at Q. Suppose this is parameter T1 and this is parameter T2. So we know that for normal chord condition is T2 is minus T1 and then minus 2 upon T1. So from here we can write value of T1 plus T2, it is equal to minus 2 upon T1. Now we need to find locus of midpoint of this chord. So let us say locus is alpha comma beta. So I'll write alpha as a t1 square plus t2 square upon 2, and beta will be 2a t1. So it will be a t1 plus t2. Now we can write this as 2 alpha upon a, and this is t1 plus t2 whole square and then minus 2 t1 t2. Now we need to eliminate t1 and t2, and we need to find relationship between alpha and beta. So we already have this t1 plus t2. We need to find the value of t1 into t2. So what we can do is, here we can put the value of t1 plus t2. So then we can write beta is equal to minus 2a upon t1. So value of t1 will be minus 2a upon beta, and from this equation if we'll take t1 as LCM, then we can also write this as t1 into t2 is equal to minus t1 square minus 2. So we'll put t1 here, so we'll get minus, and then it'll be 4a square upon beta square and then plus 2. Now we'll eliminate t1 and t2. So now we can write 2 alpha upon a, and this is t1 plus t2 whole square. So it'll simply be beta upon a whole square. So it'll be beta square upon a square and then minus 2 t1 t2. So minus 2 t1 t2 will be minus, and minus will be plus. So it'll be 2 and then 8 a square upon beta square and then plus 4. Now we'll multiply it with a. Then we can write 2 alpha, and this is beta square upon a plus 8a cube upon beta square plus 4a, and then we'll divide it with 2 also. So we can write this equation as alpha equals beta square upon 2a plus 4a cube upon beta square and then plus 2a. Now we'll replace alpha with x and beta with y. So we can write this equation as x equals y square upon 2a plus 4a cube upon y square and then plus 2a. And that's your option number 1. Now here the question is, the length of the normal drawn from a point on axis of parabola y square equals 8x, whose distance from focus is 8 units is. So we'll draw this parabola. So it is y square equals 8x. Now value of a here is 2. So focus is at a comma 0. So it will be 2 comma 0. Now any point which is at a distance of 8 units from it. So this point will be either 10 comma 0 or this point it will be, or this point will be minus 6 comma 0. Now we write equation of normal. So we know that equation of normal is given by y plus tx equals 2at. So there will be 4t and plus at cube. So there will be 2t cube. Now this normal will pass through this point 10 comma 0. So we'll put y as 0 and x as 10. So there will be 10t and this is 4t plus 2t cube. So we'll get this as 2t cube and then minus 6t equals to 0. So that means value of t is either 0 or value of t is plus or minus root 3. So that's our case 1 when we have taken this point to be 10 comma 0. Now if we'll take this point as minus 6 comma 0, then in that case we'll write this equation as y minus 6t 4t plus 2t cube. So now it will be 2t cube plus 10t equals 0. So then we'll get t equals 0 or t square plus 5 equals to 0. Now in this case we'll get only one value and that is t equals to 0. Now in this case it will be this x-axis. So we won't get any chord from this. So here we are talking about this point which is at 10 comma 0. For a chord which is drawn at any point whose t is root 3. Now in the previous video we have already discussed the formula for length of normal chord. So we know that this formula is given by L equals 4a 1 plus t square to the power 3 by 2 upon t square. Now we'll put this value. Now here the value of a is 2, so it will be 8 and then 1 plus t square. So 1 plus t square will be 4, 4 to the power 3 by 2. So there will be 2 cube. It should be 8 again and then upon t square. T square here is 3. So we'll get this length as 64 by 3. So basically the length of this normal chord drawn from this point which is 10 comma 0, it should be 64 by 3. Now this question, it's an integer type question. So I suspect they must be asking for something else which they have not clearly mentioned in the question. So this point, this is A. We can also find this point or foot of normal. So we know that this foot of normal is at square 2at. So A is 2 and t is root 3. So at square is 6 and 2at. 2at is 4 root 3. Now we'll find this length which is L dash, which is PA. So this length will be 4 square plus 4 square into 3. So there'll be what? There'll be under root of 4 cube under root 64, which is 8. And that is the answer to this question. So rather than asking for this distance Pn, they actually wrote in the question length of the normal, which is indeed incorrect because length of the normal in this case, it should be 64 by 3 and not 8. 8 is this distance, which is distance of this foot of normal from this point. The question is the number of points on y square equals 4ax at which the normal chords drawn subtend a right angle at the vertex. So we have this parabola which is y square equals 4ax. And then it says normal chord drawn at some point, say P, and this point is Q. It subtends an angle 90 degrees at the vertex. So we need to find number of such points on this parabola. So let this point is a t1 square twice a t1, and this point q be a t2 square twice a t2. Now we know that if it is normal chord, then t2 is minus t1 minus 2 upon t1. Now it also says this chord PQ, it subtends right angle at the vertex. So that means, what is the slope of this line? Slope of this line is 2 upon t1, and slope of this line will be 2 upon t2. Now since they are perpendicular, we can write 2 upon t1 into 2 upon t2 equals minus 1. So from here we can write value of t1 into t2 is simply minus 4. Now we need to find how many values are possible for t1. So we can write this equation as t1 t2 minus t1 square minus 2. Now t1 into t2 is minus 4. So we can write t1 square equals 2. So value of t1 is plus or minus root 2. So the number of points at which normal chords drawn subtend a right angle at vertex is simply 2. For the parabola y square equals 4ax, a normal chord AB is drawn at a point A such that AB is shortest. So basically here we are talking about the shortest normal chord, and then we need to find circumcenter of this triangle OAB. Now we have this parabola which is y square equals 4ax, and then we have this normal chord which is AB. Now we want this normal chord to be of shortest length. So in one of the previous video, we have already discussed that length of a normal chord is given by 4a t1 square plus 1 to the power 3 by 2 upon t1 square if it is drawn at this point, which is a t1 square twice a t2. And suppose this other end is a t2 square twice a t2. Now we need to minimize it. So what we'll do is we'll square it and then we'll differentiate. So we'll write L square as 16a square t1 square plus 1 whole cube upon t1 to the power 4. Now we'll differentiate with respect to t1. So we'll write 2L dl upon dt1. It'll be 16a square, and then we can write t1 to the power 4 3 t1 square plus 1 whole square into 2t1, and then minus it'll be t1 square plus 1 whole cube into 4 t1 cube. Now we'll take 2 t1 cube and t1 square plus 1 whole square common. So we'll take it common. We'll write 16a square, and then we'll write 2 t1 cube and then t1 square plus 1 whole square. So then we'll get 3t1 square and then minus 2 t1 square plus 1. And for maxima and minima, we'll need to find its critical point. So we'll put it equals to 0. Then we'll get 32a square t1 cube t1 square plus 1 whole square, and then it will be t1 square minus 2 equals to 0. So we'll get value of t1 as plus or minus root 2, and we'll also get t1 as 0. So we'll plot these roots on a number line. We'll get minus root 2, 0 and plus root 2. Rightmost is plus, so it is plus, minus, plus and minus. So we'll get a minima when the value of t is either plus root 2 or minus root 2. So length of this normal chord, it will be minimum when the value of t1 is, say, root 2. So if the value of t1 is root 2, we can write this point A as at1 square twice at1. So it will be 2a and 2 root 2a. Now we'll write this point B. Now we know that relationship between t1 and t2 is t2 equals minus t1 minus 2 upon t1. So we'll put t1 as root 2. We'll write minus root 2 and then minus root 2. So actually value of t2 is minus 2 root 2. So now we can write B also. So coordinate of this point B it will be 8t square. It will simply be 8a, 282. So it will be minus 4 root 2a. Now we need to find circumcenter of this triangle OAB. Now we'll find slope of OA. So we know that slope of OA is 2 root 2a upon 2a. So it'll simply be root 2, and we'll find slope of OB. Slope of OB is minus 4 root 2a upon 8a. So it'll be minus 1 upon root 2. So we look at it, we'll find m1 into m2 is minus 1. So if product of slope is minus 1, it means this angle is 90 degrees. So this triangle OAB, it is a right angle triangle. Now in a right angle triangle, circumcenter is midpoint of hypotenuse. So that means circumcenter of this triangle OAB, which is say S, it is given by midpoint of A and B. Now A is 2A and B is 8A. So S is given by 2A plus 8A by 2, and then 2 root 2a minus 4 root 2a by 2. So circumcenter of this triangle will be at 5a minus root 2a. Now we'll take TS minus root 2, then we'll get another result, and I think that result will be 5a comma root 2a. So there'll be two answers possible in this question. Now the question is, if the normals to parabola y square equals 4x drawn at end point of its latest rectum are tangents to circle x minus 3 square plus y plus 2 square equals r square, then the value of r square is. Now we know that for this parabola, value of a is 1, and we also know that for n points of latest rectum, value of t is plus 1 or minus 1. So we can write equation of normal as y plus tx equals at cube plus 2at. Now we'll put the value of a and t. Now here a is 1, and let us take t as 1. So we can write this equation as y plus x equals 3. So one of the normal is x plus y minus 3 equals to 0. Now it says this normal is tangent to this circle. So for this circle, center is at 3 comma minus 2. And if this line is tangent to this circle, then perpendicular distance from center must be equal to its radius. So that means we can write r equals 3 minus 2 minus 3 upon root 2. So it will be simply root 2. So value of r square will be 2. So answer to this question is 2. Now here the question is, if normal at P on y square equals 4ax cuts the axis of parabola in G, and if S is focused, then SG is equal to what? So we have this parabola, which is y square equals 4ax. Then at any point P, we draw a normal which cuts axis at this point G, and suppose focus is S, which is a comma 0. Now we know that at any point P, which is say at square 2at, equation of normal is y plus xt equals at cube plus 2at. Now this normal, it intersects axis at G. Now that means for G, its y coordinate is 0. So its x coordinate will be at square plus 2a. So coordinate of G will be at square plus 2a comma 0. Now we need to find this distance SG. So this distance SG is simply at square plus 2a and then minus a. So it will simply be a plus at square. So that is a 1 plus t square. And we know that this is focal distance, which is equal to simply SP. So that means answer to this question is option number 1. Now the second question is, If normal at P cuts the axis of parabola in G and S is the focus of parabola, if this triangle SPG is equilateral triangle. So that means this triangle, it is an equilateral triangle. Then we need to find length of each side. This distance SG must be equals to PS and it must be equals to PG. Now this SG and PS, they're equal, and we know that it is A plus AT square. So it is A plus AT square. And what is this distance? So this P is AT square comma 2AT and G is A plus AT square comma 0. So this distance will be under root of A square plus 2AT square. So we'll write A square, and this is 1 plus T square whole square, and it will be A square, and this is 1 plus 4T square. So this A square will cancel. So we can write this equation as 1 plus T to the power 4 plus 2T square, and this is 1 plus 4T square. So we'll take this 4T square on the left, then it will be 1 plus T4 minus 2T square. So we can write it as T square minus 1 whole square equals to 1. So it will be T square minus 1 equals plus 1 or minus 1. So we'll take plus 1. Then we'll get value of T as plus or minus root 2. And if we'll take minus 1, then the value of T, it will be 0. If T is 0, it won't form a triangle. So that means the value of T should be plus or minus root 2. So now we need to find length of this equilateral triangle. So we know that this length of equilateral triangle is A plus AT square, A1 plus T square. What's T square? T square in this case is 2, which is simply 3A. So length of side of equilateral triangle is simply 3A. Now here the question is, P is a point P on parabola, y square equals 4ax, and PQ is the focal chord, PT is a tangent at P, and QN is a normal at Q. Then if the angle between PT and QN be alpha, and the distance between PT and QN be D, then we'll need to find the value of alpha and D. So we'll draw this parabola. Now P is any point on this parabola, which is AT square 280, and then we'll draw a tangent at this parabola. So PT is tangent at P. Now it also says this PQ, it's a focal chord. So we have this PQ and it's a focal chord. So it passes through A comma 0 and Q is A T2 square twice A T2, and since PQ it is focal chord, we know that T1 into T2 is equal to minus 1. Now we draw normal at Q. This is tangent at Q, and then we have normal at Q. Suppose this is QN. Angle between PT and QN, it says this angle is alpha, and D is the distance between PT and QN. We need to find the value of alpha, and we need to find the value of D. Now it is given that T1 into T2 is minus 1. Slope of PT is equal to slope of tangent, and slope of tangent is 1 upon T1. Now at Q, what is slope of normal? So slope of normal is simply minus T2. We can write minus T2 as 1 upon T1. So it is also 1 upon T1. So basically these two lines, they'll be parallel. So that means clearly in this case, value of alpha should be 0. Now if the value of alpha is 0, then we need to find distance between these two lines. So we know that equation of tangent at this point P will be Ty equals x plus at square, or T1y equals x plus at1 square. Now what is equation of normal at point Q? Equation of normal at point Q will be y plus t2x equals a t2 cube plus twice a t2, and we know that t2 is minus 1 upon t1. So we can write this as y and then minus 1 upon t1x, and this is minus a upon t1 cube minus 2a upon t1. So we can rewrite this equation as t1y minus x, and this is minus a upon t1 square and then minus 2a. Now we need to find distance between these two parallel lines. So distance between these two parallel lines will be c2 minus c1. So we can write a t1 square and then plus a upon t1 square plus 2a upon and then under root of a square plus b square. So it will be t1 square plus 1. So we'll take a common. We can write this as t1 plus 1 upon t1 whole square upon under root of 1 plus t1 square. So here it will be a, and then we can write this as t1 square plus 1 whole square upon t1 square and then under root of 1 plus t1 square. So we can write this distance as a, and then it will be t1 square plus 1 to the power 3 by 2 upon t1 square. So value of alpha should be 0 and value of d should be a t1 square plus 1 to the power 3 by 2 upon t1 square, which is your option number B. Now the question is, the normals AO, AA1 and AA2 are drawn to parabola from this point h, 0. If the triangle is equilateral, we'll need to find possible values of h. So you have this parabola which is y square equals 8x and then some point which is a h, 0. Three normals are drawn. So this is point O, and then we have these points A1 and A2. So we know that equation of normal will be y equals mx minus am cube. A in this case is 2, so it will be 2m cube and then minus 2am. So it will be simply 4m, and this normal will pass through this point h, 0. So we'll put y as 0 and x as h. So we'll let 0 mh minus 2m cube minus 4m. So we'll get one of the value of m as 0, so which is this line OA, and then we'll have this other condition which is 2m square equals h minus 4. So in this case we'll get the value of m as plus or minus under root of h minus 4 by 2. Now we know that for any normal, foot of normal is am square minus 2am. Now it also says this triangle OA1A2 is an equilateral triangle. So we can write this as 1030, and it should be equals to y2 minus y1 upon x2 minus x1. So it will be minus 2am1 upon a m1 square. So I'll cancel this. So we'll cancel this. So we'll write 1 upon root 3, and this is minus 2 upon m1. So we'll square, we'll write this as m1 square must be equal to 12. Now we'll put the value of m1 square. So we'll square it, we'll get h minus 4 upon 2 equals 12. So that is value of h should be 28, and that's your option number C. Now the question is, locus of foot of perpendicular from focus on any normal to this parabola is. So we have this parabola which is y square equals 4ax, and then at any point P we have drawn a normal, and then from focus which is a, 0, we need to find locus of foot of perpendicular. So let us say this point is alpha, beta, and suppose it is this point A. So we need to find locus of this point A. Let this point be at square 2at. So we can write equation of normal as y plus tx equals at cube plus 2at. Now we can write this equation as tx plus y and then minus at cube plus 2at comma 0. Now we'll find foot of perpendicular from focus on this line. So we can write this as alpha minus a upon t, and this is beta minus 0 upon 1, and this is minus, and then we'll put the value of x and y. So x is a, so it will be at plus 0 minus at cube minus 2at upon t square plus 1. So we can write this as alpha minus a upon t equals beta upon 1. Now here will be at minus 2at, so it will be minus at, so we'll take minus at common, so we'll get at, and then we'll get 1 plus t square upon 1 plus t. So we can cancel this 1 plus t square. So from this first one we can write alpha minus a is equal to at square, and from the second one we'll get beta equals at. Now we'll eliminate the value of t, so we can write this equation as alpha minus a equals a, and then t square will be beta square upon a square. So we'll cancel this a, so we can write this equation as y square equals to a into x minus a, and that's your option number A. Now here the question is, AB is the chord of the parabola y square equals 4x such that normals at A and B intersect at a point C 9, 6. So for this parabola, if we write equation of normal, it will be y equals mx minus am cube. Now a in this case is 1, so it will be simply m cube minus 2m. Now it will pass through this point 9, 6. So here y is 6 and x is 9, so it will be 9m minus m cube minus 2m. So we can write this as m cube minus 7m and then plus 6 equals to 0. So we'll write this as m cube minus m and then minus 6, m minus 1 equals to 0. So we can take m minus 1 common, and then we'll get m square plus m minus 6 equals to 0. So it'll be m minus 1 and then m minus 2, m plus 3 equals to 0. So we'll get three values of m. Either the value of m is 1 or m is 2 or the value of m is minus 3. So these 3 points, they represent co-normal points and their slopes are 1, 2 and minus 3. So now we have this parabola which is y square equals 4ax. And then we have this point C which lies on this parabola. And then we have these foot of normals. So we can find foot of normals which are am square minus 2am. Now here the value of a is 1. So if m is 1, we'll get this point as 1 comma minus 2. If m is 2, we'll get this point as 4 comma minus 4. And if we'll take m as minus 3, then we'll get this point as 9 comma 6. So that means this point C is 9 comma 6, and then we have 2 points, one of which is 1 comma minus 2, and that's your suppose A. So A is 1 comma minus 2 and B is 4 comma minus 4. Now first question is we need to find length of AB. So length of AB, it will be under root of, now this is 3 square 9 and then it will be 2 square 4. So it should be under root of 13. So this A, it is matched to R. Second one is area of this triangle ABC. So we can find this area as 1 by 2. Now x1, y1, 1. So it will be 1 minus 2, 1. 4 minus 4, 1. And then 9, 6 and 1. Now we'll take R1 minus R2 and R2 minus R3. So we can write this as 1 by 2 will be what? Minus 3 plus 2, 0. And now here it will be minus 5 minus 10, 0, and this is 9, 6 and 1. So we can write this area as 1 by 2 and will be 30 and plus 10, so that should be 40 and it is 20. So area of this triangle ABC is simply 20 units. So option B, it is matched to B. Now third one is perpendicular distance from origin of this line AB. So here we'll need to find equation of this line AB. So first we'll find the slope. So its slope will be y2 minus y1. So it will be 2 and upon minus 3. And we can write this equation as y plus 2 minus 2 by 3 x minus 1. So it will be 2x plus 3y plus 4 equals to 0. Now we'll find its perpendicular distance from origin. So perpendicular distance from origin will be 4 upon, now it will be what, 9 and plus 4 root 13. So it will be 4 by root 13. So C, it is matched to Q. Now the last one is area bounded by the coordinate axis and the line through AB. So we'll find intercepts. So the modulus value of intercepts will be 2 and 4 by 3. So once we have these intercepts, we can write this area as half AB. So it will be 2 into 4 by 3. So option D, it is matched to S. Now here the question is, AB is the chord of the parabola y square equals 4x such that normals at A and B intersect at a point C 9, 6. So for this parabola, if we write equation of normal, it will be y equals mx minus am cube. Now A in this case is 1. So it will be simply m cube minus 2m. Now it will pass through this point 9, 6. So here y is 6 and x is 9. So it will be 9m minus m cube minus 2m. So we can write this as m cube minus 7m and then plus 6 equals to 0. So we'll write this as m cube minus m and then minus 6, m minus 1 equals to 0. So we can take m minus 1 common and then we'll get m square plus m minus 6 equals to 0. So it'll be m minus 1 and then m minus 2, m plus 3 equals to 0. So we'll get 3 values of m. Either the value of m is 1 or m is 2 or the value of m is minus 3. So these 3 points, they represent co-normal points and their slopes are 1, 2 and minus 3. So now we have this parabola which is y square equals 4ax. And then we have this point C which lies on this parabola. And then we have these foot of normals. So we can find foot of normals which are am square minus 2am. Now here the value of a is 1. So if m is 1, we'll get this point as 1 comma minus 2. If m is 2, we'll get this point as 4 comma minus 4. And if we'll take m as minus 3, then we'll get this point as 9 comma 6. So that means this point C is 9 comma 6 and then we have 2 points, one of which is 1 comma minus 2 and that's your suppose A. So A is 1 comma minus 2 and B is 4 comma minus 4. Now first question is we need to find length of AB. So length of AB, it will be under root of, now this is 3 square 9 and then it will be 2 square 4. So it should be under root of 13. So this A, it is matched to R. Second one is area of this triangle ABC. So we can find this area as 1 by 2. Now x1, y1, 1. So it will be 1 minus 2, 1, 4 minus 4, 1, and then 9, 6 and 1. Now we'll take R1 minus R2 and R2 minus R3. So we can write this as 1 by 2 will be what? Minus 3 plus 2, 0. And now here it will be minus 5, minus 10, 0, and this is 9, 6 and 1. So we can write this area as 1 by 2 and will be 30 and plus 10, so that should be 40 and it is 20. So area of this triangle ABC is simply 20 units. So option B, it is matched to B. Now third one is perpendicular distance from origin of this line AB. So here we'll need to find equation of this line AB. So first we'll find the slope. So its slope will be y2 minus y1. So it will be 2 and upon minus 3. And we can write this equation as y plus 2 minus 2 by 3 x minus 1. So it will be 2x plus 3y plus 4 equals to 0. Now we'll find its perpendicular distance from origin. So perpendicular distance from origin will be 4 upon, now it will be what, 9 and plus 4 root 13. So it will be 4 by root 13. So C, it is matched to Q. Now the last one is area bounded by the coordinate axis and the line through AB. So we'll find intercepts. So the modulus value of intercepts will be 2 and 4 by 3. So once we have these intercepts, we can write this area as half AB. So it will be 2 into 4 by 3. So option D, it is matched to S. Now here the question is, we need to find locus of midpoint of chord of parabola y square equals 4ax when it passes through focus. So that means we'll need to find midpoint of focal chord of a parabola. We know that for any parabola, if we are given midpoint of a chord, then equation of chord is given by t equals s1. So what we'll do is, we'll take this midpoint as some p and say it is alpha comma beta. Now for this chord, we'll find t equals s1, which is the equation of this chord. So equation of this chord will be t will be beta y minus 4a x plus alpha by 2, and it will be equal to beta square minus 4a alpha. We can write this equation as beta y minus 2ax minus 2a alpha, and this is beta square minus 4a alpha, or beta y minus 2ax minus beta square plus 2a alpha equals 0. Now first question is, it passes through focus. So if it passes through focus, that means it'll pass through a comma 0. So we'll put x as a and we'll put y as 0. So it'll be minus 2 a square minus beta square and plus 2a alpha equals 0. Now we'll replace alpha with x and beta with y. So we'll get this locus as y square equals 2ax minus 2a square. So we'll take 2a common. So it'll be y square 2a x minus a. So option number A, it matches with R. So A matches with R. Now the second question is, we need to find locus of midpoint of normal chord. So we have this parabola and then we have this normal chord, which is a t1 square twice a t1 and a t2 square twice a t2, and for normal chord we know that t2 is minus t1 minus 2 upon t1. We need to find locus of midpoint. Say it is alpha and beta. So we can write alpha as a t1 square plus t2 square upon 2, and we can write beta as a t1 plus t2. So we can write this as 2 alpha upon a, and we'll add 2 t1 t2. So it will be t1 plus t2 whole square minus 2 t1 t2, and here t1 plus t2, it will be beta upon a. Now from here we can also write t1 plus t2 as minus 2 upon T1. So we'll replace the value of T1 plus T2. Then we can write beta upon A is minus 2 upon T1. So basically T1 will be minus 2A upon beta. Now once we have T1, we can also find T1, T2. So we'll multiply T1. We can write T1, T2 as minus T1 square minus 2. So it'll be minus and then 4A square upon beta square minus 2. So now we'll put the value of T1 plus T2 and T1 into T2. So it'll be 2 alpha upon A, and this is T1 plus T2 square. T1 plus T2 square is beta upon A square. So it'll be beta square upon A square minus 2 T1 T2. So it'll be minus and minus will be plus. So it'll be 8A square upon beta square plus 4. Now we'll take A square beta square as LCM. So we'll get 2 alpha upon A, and will be beta to the power 4 plus 8A to the power 4 plus 4 A square beta square upon A square beta square. Now A and A square, so we'll cancel. So we can write this equation as 2A alpha beta square equals beta to the power 4 plus 4 A square beta square plus 8 A to the power 4. Now we'll take everything on the right hand side. Then we can write this equation as beta to the power 4, and then we'll take 2A beta square common, and we'll get 2A minus alpha plus 8 A to the power 4 equals to 0. Now in the end we'll replace beta with y and alpha with x. So this equation will be y to the power 4 plus 2A y square 2A minus x plus 8 A to the power 4 equals to 0, and that's your option S. So that means B, it is matched to S. Now the third question is, we need to find locus of midpoint of chord for which line joining origin to extremities of chord are equally inclined to the axis of parabola. So we have this chord, and line joining these extremities, they are equally inclined to coordinate axis. So we know that if the lines are equally inclined to coordinate axis, then its slope will be plus 1 and minus 1. For this chord, say AB, this slope is m1, and this is a t1 square twice a t1, and this is a t2 square twice a t2. So if we'll find the slope, it will be 2a upon t1, it is 1. So we can write t1 as 2a, and in the same way 2a upon t2 is minus 1. We'll write t2 as minus 2a. Now we need to find locus of midpoint. So alpha is a t1 square plus t2 square upon 2, and beta is a t1 plus t2. Now t1 plus t2 is actually 0. So we'll get this locus as beta equals 0, which is simply y is equal to 0, and that's your option number B. Now the fourth one is, we need to find locus of midpoint of the chord whose length is L. So again, we'll get this alpha as a t1 square plus t2 square upon 2, and we'll get beta as a t1 plus t2. Now from here we'll write t1 square plus t2 square, it is 2 alpha upon a, and t1 plus t2 is beta upon a. Now we'll square it, we'll get t1 square plus t2 square plus 2t1 t2, and will be equal to beta square upon a square. Now we'll put the value of t1 square plus t2 square, then we can write 2t1 t2 as beta square upon a square minus 2 alpha upon a. Now we have t1 plus t2 and we have 2t1 t2. We need to find locus of midpoint of chord whose length is L. So we know that formula for length of the chord is L equals A T2 minus T1 under root of T1 plus T2 whole square plus 4. Now we'll square it. If we'll square it, we'll get L square equals A square and it'll be T2 minus T1 whole square. And this is T1 plus T2 whole square plus 4. So we can write this equation as L square is equal to A square. Now T1 minus T2 whole square, we can write T1 plus T2 whole square minus 4 T1 T2, and here it will be T1 plus T2 whole square plus 4. T1 plus T2 is nothing but beta upon A. So we can write this equation as L square equals A square, and now T1 plus T2 will be beta upon A. So it will be beta square upon A square minus 4 T1 T2. Minus 4 T1 T2 will be minus 2 and then beta square upon A square minus 2 alpha upon A, and again here it will be beta square upon A square plus 4. Now we'll take LCM and simplify. We'll write this as L square equals A square and it will be 4A alpha minus beta square upon A square, and it will be beta square plus 4A square upon A square. Now A square will cancel. We can write this equation as A square L square equals 4A alpha minus beta square and beta square plus 4A square. Now we'll replace alpha with x and beta with y. So its equation will be A square L square 4ax minus y square into y square plus 4a square. So that is the locus of required midpoint. And that's your option number Q. So that means this D, it is matched to Q. We generally study questions on number of common tangents between two curves. Now here the question is, we have to find maximum number of common normals that can be drawn to these two parabolas. Y square equals 4ax and x square equals 4by. So what I'll do is, I'll start with this first equation. For the parabola of the first form, equation of normal is y equals mx minus am cube minus twice am. Now I'll consider the second equation, which is x square equals 4by. Now the relation between first and third form is, if I interchange x and y, I'll get third form, x square equals 4ay, or in this case, which is x square equals 4by. So for this equation, I can write equation of normal as x equals m dash y minus b m dash cube minus 2b m dash. So again, what I'll do is, I'll write it as m dash y equals x plus b m dash cube plus twice b m dash. I'll divide by m dash. I'll write y equals 1 upon m dash x plus b m dash square plus 2b. So that is the equation of normal for this second form, x square equals 4by, and for the first form, equation of normal is y equals mx minus am cube minus twice am. Now we are looking for common normal. So we are looking for equation of a line which is normal to both the curves. So that means both the equations should represent same line. So if both the equation represent same line, in that case, if I'll compare coefficient of x, I'll get m equals 1 upon m dash, and also I'll get am cube minus twice am, and this is b m dash square plus 2b. So from here I'll write m dash as 1 upon m. So I'll write am cube minus twice am b upon m square plus 2b. So if I'll multiply, I'll get minus am to the power 5 minus twice am cube plus b plus 2b m square. So I can write this equation as am to the power 5 plus twice am cube plus 2b m square plus b equals to 0, which is an equation of degree 5. So any fifth degree equation can have at most 5 real roots. So this equation will have at most 5 real roots. Now, most of the books and almost all YouTube videos and study material, they give the maximum number of common normals between the two given parabolas, y square equals to 4ax and x square equals 4by as 5. Now, this fifth degree equation, it may not have 5 real roots. So what we'll do is, we'll look at this equation a bit. I'll divide this equation with a. So I'll write m to the power 5 plus 2m cube plus 2 b upon a m square plus b upon a equals to 0. Now I'll take this b upon a as some other constant, which is lambda. So I'll write this equation as m to the power 5 plus 2m cube plus 2 lambda m square and then plus lambda equals to 0. So I can write this equation as m to the power 5 plus 2m cube, and then I'll take everything on the right hand side. I'll write minus lambda, and this is 2m square plus 1. So we can rewrite this equation as m to the power 5 plus 2m cube upon 2m square plus 1, and this is equals to minus lambda. Now, if we'll consider a function fx, which is x to the power 5 plus 2x cube upon 2x square plus 1. So domain of this function is x belongs to R. Now, if we'll differentiate this function, if we'll find f dash x, then derivative of this function will be 6x to the power 6 plus 9x to the power 4 plus 6x square upon 2x square plus 1 whole square. Now, since all the powers of x, they are even powers, so that means this expression is always greater than or equal to 0. So that means this function, it is an increasing function in x belongs to R. So we'll draw the graph of this function. This function will be an increasing function. Now we'll need to find number of solutions of this equation, which is x to the power 5 plus 2x cube upon 2x square plus 1 equals minus lambda. So one of the function is x to the power 5 plus 2x cube upon 2x square plus 1, and the other function is y equals minus lambda, which is a straight line which is parallel to x-axis. So if I draw this straight line, so this straight line, it will intersect the graph at only one point. So there'll be no other point of intersection. So even when this equation of degree 5, it cannot have 5 real roots. So the only possibility in this case is it will always have exactly one real root for all values of a and b when a and b, they are unequal to 0. So maximum number of common normals between these two given parabolas will always be 1 and not 5. If you have ever wondered if there is a general formula for number of normals in a given parabola y square equals to 4ax, and yes, there is a formula for that. So if you have a parabola y square is equal to 4ax, and we have to find number of normals that can be drawn through the point x1 y1, where x1 is unequal to 2a or y1 is unequal to 0, because it is a very trivial case. So we are considering a general case. So in this case, we'll let h as 2a minus x1 upon 3a and g as minus y1 upon a, and we'll define delta as g square plus 4h cube. Now if delta is greater than 0, the number of normals that can be drawn through that point is 1. If delta is equal to 0, number of normals is simply 2. And if delta is less than 0, then number of normals is 3. So we need to prove this formula. So for this parabola, y square is equal to 4ax, we know that equation of normal is given by y equals mx minus am cube minus twice am. Now we need equation of normal that passes through the point x1 comma y1. So I'll put the value of this point here. So I'll write y1 equals to mx1 minus am cube minus twice am. So I'll rearrange this equation. I'll write am cube plus 2a minus x1 into m and then plus y1 equals 0. I'll divide by a also. So I'll write n cube plus 2a minus x1 upon a into n and then plus y1 upon a equals 0. Now we have taken 2x minus x1 upon 3a as h and minus y1 upon a as g. So if I replace this equation in terms of h and g, so then I can write this equation as n cube. Now 2n minus x1 upon a, it is 3h. So I'll write plus 3hm and y upon a. So y1 upon a is simply minus g. So it is minus g and this is equals to 0. So we'll get a cubic equation which is n cube plus 3hm minus g equals to 0. Now once we have this cubic equation, I'll write this function fm as n cube plus 3hm and then minus g. If I'll differentiate, I'll write f dash m as 3m square plus 3h. Now if I take this first case, when h is positive, in that case f dash m, and which is 3m square plus 3h is always greater than 0. So in that case, it will always be an increasing function. So if it is an increasing function, then it will intersect x-axis only at one point. So in that case, it will have only one normal. So we'll have only one normal when h is greater than 0. So if h is greater than 0, in that case, this delta, which is g square plus 4h cube. Now g square is positive, h is also positive. So in this case, delta, it should be 0. Now we'll consider the case when h is less than 0, when h is negative. We are not considering the case when h is 0 because we have already taken the condition that x1 is unequal to 2a. In that case, we'll have only one normal. Now when h is less than 0, then in that case, we can write f dash m as 3m square plus 3h equals to 0. Then I'll write m square as minus 3h. Then m will be plus or minus under root of minus h. So if I'll plot, I'll get minus under root of minus h and plus under root of minus h. Now what is the sign of the rightmost? So it is plus, minus and plus. Now at minus of under root of minus h, the sign changes from plus to minus. So that means it is a point of local maxima, and at minus under root of minus h, sign changes from minus to plus, it is a point of local minima. So I'll find the values at this point. I'll find the value of f minus of under root of minus h. So if I'll put the value of this, I'll get it as minus under root of minus h cube and then plus 3 h, and in place of m, I'll write minus of minus under root h and then minus g. So I'll write it as, so it is minus and then minus h square again will be plus, so h into under root of minus h, and here I'll get minus 3h into under root of minus h and then minus g. So which is minus twice h into under root of minus h and then minus g. If I'll find f under root of minus h, so if I'll put f under root of minus h, I'll get minus h into under root of minus h. Here it'll be minus 3h under root of minus h plus 3h under root of minus h and then minus g. So in that case, I get twice h under root of minus h and then minus g. So this is the value of local maximum and that is the value of local minima. Now for h less than 0, we'll consider the first case when this equation will have only one normal. Now for only one normal, both of them either they should be positive or both of them should be negative. So in this case, I'll get this condition as f of minus under root of minus h into f of under root of minus h, it should be greater than 0. Either both of them positive or both of them negative. So I'll write this as, so what is f of minus under root of minus h? So it is minus 2h under root of minus h minus g, and it is twice h under root of minus h minus g. It should be greater than 0. So I'll take this minus sign common. So I'll write twice h under root of minus h plus g and twice h under root of minus h minus g should be greater than 0. So I'll write minus and then it will be 4h square into minus h and then minus g square should be greater than 0. So if I'll multiply this minus sign, I'll get 4h cube plus g square and it should be greater than 0. Now 4h cube plus g square is nothing but delta. So from here I'll get this condition as delta is greater than 0. So when h is greater than 0, for one normal condition is delta should be greater than 0. When h is less than 0, then to the condition is delta should be greater than 0. So we'll get our first condition that whichever way delta is greater than 0, then the number of normal will be simply 1. Now we'll come to the second case, two normals. Now for two normals, so that means this cubic equation should have equal roots. So in that case, the graph should be either this or it should be in this way. So in this case, at least one of this f of minus of under root minus h or f of under root of minus h, one of them should be 0. So in that case, I can write the condition as f under root of minus h into f under root of minus h, it should be 0. And we have already done this. We have multiplied them previously. If we'll multiply, we'll get 4h cube plus g square is equal to 0. So from here, the condition will be delta is equal to 0. So if the value of delta is 0, then in that case, number of normals will be simply 2. Now, if we have to find the condition that 3 normals can be drawn to this point, then in that case, this equation should have 3 real roots. So this equation will have 3 real roots when the graph will be drawn like this, right? So in this case, we know that one of the values should be positive and the other value should be negative. So in that case, f minus of under root of minus h into f under root of minus h, this should be less than 0. Again, we have already multiplied it. So this value will be 4h cube plus g square and then it should be less than 0. So when delta is less than 0, in that case, we'll have 3 normals. So this is the general formula to find number of normals in a parabola passing through the point x1 comma y1 for any general point except when x1 is unequal to 2a or y1 is unequal to 0. So now here the question is, consider the parabolas y minus 2 whole square equals 4x minus 2 and x minus 2 whole square equals 4y minus 2, and let S be the largest circle touching the two parabolas internally in the bounded region. Find the center and radius of the circle. So here we have two intersecting parabolas and we have to find radius of this largest circle which touches both the parabolas. Now if I look at equation of two given parabolas, they are y minus 2 whole square equals 4x minus 2 and x minus 2 whole square equals 4y minus 2. Now what we'll do is we'll shift the origin to their point of intersection, which is 2, 2, so that this problem, it simplifies a bit. So what we'll do is, we'll let x minus 2s some capital X and y minus 2s some capital Y. Then we have equation of two parabolas as x square equals 4y and y square equals 4x. So basically what we'll do is, we'll solve the problem for these two standard equations. We'll find the center and radius of the circle by shifting the origin again. So now we have this situation where we have our two new axes, and here we have two parabolas as capital Y square equals 4x and x square equals 4y. Now they'll intersect at origin, and if we equate them, the other point of intersection will be 4, 4. And we need to find radius of the largest circle which is going to touch both the parabolas. Now, just by looking at these two equations, we know just by interchanging x and y in one, we'll get the other equation. So basically these two parabolas, they are a reflection of each other about y equals x line. So these two parabolas, they are inverse curve of each other and they are reflection of each other about y equals x line. Now from symmetry we can establish that center of this circle, it will lie on this line which is y equals x. Now previously while solving the question, I made an assumption that center of the circle will be midpoint of 0, 0 and 4, 4, which essentially is incorrect. Now the problem here is, I completely forgot these are the branches of parabola and not circles. In case of a circle, symmetry is preserved and this maximum distance will be at the midpoint. But in case of parabola, if you want to look at it, this distance, it is not maximum at this midpoint 2, 2. So this assumption that center of the circle is at 2, 2 is incorrect. And that is the reason I have to rework this problem. Now, how do we solve it? Now, essentially it is clear that center of the circle will lie on y equals x line. Now we are not going to assume that it is 2, 2, but the center of the circle, it still lies on a y equals x line. And suppose this point of contact of this circle and parabola y square equals 4x is some point A, and if we write it in terms of parametric coordinates for this standard parabola y square equals 4x, it will be t square, 2t. Now at this point A, this circle and parabola, they'll be tangent to each other. That means normal to this parabola will also be normal to the circle. So normal to parabola at this point A will pass through center of the circle. Now if we write equation of normal at A, it will be given by y plus tx and it will be equal to at cube plus 2at, and a in this case is 1, so it will be t cube plus 2t. Now basically center of the circle, it is nothing but it is intersection of this normal with y equals x line. So if we put x equals y, we'll get x equals y equals t cube plus 2t upon 1 plus t, that is center of the circle will be t cube plus 2t upon 1 plus t and t cube plus 2t upon 1 plus t. Now we have to maximize this radius. Now if we use distance formula, then we'll get this radius as r square equals 2 minus t upon 1 plus t square into t square plus T4. Now we have to maximize this radius. Now since it requires a lot of calculation, what I did was I used Wolfram alpha, and from there it says we'll get maximum value of R as 1 by root 2, and we get this value when the value of T is 1. Now we have radius and we also have center. We can solve this problem. But I did not like this approach because of this complicated expression. So another thing that struck me was, if we consider these two parabolas, y square equals 4ax and x square equals 4ay, and this is our y equals x line. So if I take a point t square comma 2t, what I can do is I can find the maximum distance of this point from y equals x line. So that's how we can find maximum value of this radius r. So if we find this distance, say r, will be x minus y, and x minus y will be t square minus 2t upon root 2 with a mod sign. But as of now, we'll ignore it. So we differentiate dr by dt, we'll get this as 2t minus 2 upon root 2 equals 0. Value of t is 1. And basically we have this mod sign here. So if we are going to check, then we'll get a local maximum at t equals 1. And if we put t equals 1, we'll get the value of r as 1 by root 2. So this approach is a better approach. So here we have r, which is 1 by root 2. And once we have t, this point A, it is 1 comma 2. And if we put t as 1, we'll get this as 1 plus 2, 3 upon 1 plus 1, 2. So this point or center of the circle will be at 3 by 2 and 3 by 2. And since this other parabola, it is a reflection of the first parabola, so corresponding point on this parabola will be 2 comma 1. So once we have this point and radius, we can write equation of this circle. So equation of this circle will be x minus 3 by 2 square plus y minus 3 by 2 square, and will be equal to 1 by root 2 square, which is 1 by 2. But this is equation of circle for these parabolas. Capital Y square equals 4x and capital X square equals 4y. We have to find it for the given parabolas. So what we'll do is we'll simply replace x with x minus 2 and capital Y with y minus 2. So we can write equation of this circle as x minus 2. So it will be this x minus 7 by 2 square plus y minus 7 by 2 square, and will be equal to 1 by 2. So center of this circle will be at 7 by 2 comma 7 by 2, and its radius will be 1 by root 2. And this point 1 comma 2, say this point A will be this x minus 2 equals 1. So it will be this 3 comma 4, and this other point B will be 4 comma 3. Now we come back to its graph. This point is 3 comma 4. This other point is 4 comma 3, and this is 3.5 comma 3.5, and radius of this circle is 1 by root 2. I would like to thank Ankit, who pointed out error in the solution. So problem with the previous solution was assumption of symmetry. Though it is correct that center of the circle will lie on y equals x line, but it won't be at 2 comma 2 because these are not two intersecting circles. They are intersecting parabolas, and as we can see, they are sloping differently at these 2 points. At 2 comma 2 we have a different angle, and at 4 comma 4 we have another angle. Now the question is, if the parabola y square equals 4ax and y square equals 4c x minus b have a common normal other than x-axis and b upon a minus c is greater than k, we need to find this value of k. Now we can write equation of normal for this parabola. So for this parabola, equation of normal will be y equals mx minus am cube minus 2am. Now we can write equation of normal to this parabola also. So it will be y equals m. Now in place of x, we'll write x minus b. And then minus, now a here is c, so it will be cm cube minus 2cm. Now we have a common normal. So that means these two equations, they represent the same line. So if we'll compare the constant terms, we'll write minus am cube minus 2am is equal to minus bm minus c m cube minus 2cm. Now what we'll do is we'll take these terms of m cube together and we'll take terms of m together. So we can write this as a minus c m cube and it is equal to 2c minus 2a plus b into m. So now here one of the values m equals to 0, but there'll be x-axis. So we need roots other than x-axis. So we can write this as a minus c m square and this is equal to 2 times c minus a plus b. So value of m here should be plus minus under root of 2 c minus a plus b upon a minus c. So we can write this as plus minus under root of b upon a minus c minus 2. Now in order to have a common normal, this value of m, it should be real. So it is real when b upon a minus c minus 2, it is greater than 0. So that means b upon a minus c, it should be greater than 2. So the value of k here is 2. Now here the question is, if the two different tangents of y square equals 4x are normal to x square equals 4ky and 8k square is less than alpha, we need to find the value of alpha. Now for this first form, we know that equation of tangent is given by y equals mx plus a by m, and a in this case is 1, so it will be simply y equals mx plus 1 by m. And in one of the previous videos, we have also discussed how to write equation of normal for this third form. So equation of normal to this third form in terms of slope is given by y equals mx plus a by m square plus 2a. Now a in this case is k, so it will be k by m square plus 2k. Now the question says these two different tangents are actually normals to this parabola. So that means these two equations, they represent the same lines. So if they represent the same line, then their constant term, they must be same. So we'll compare their constant terms. We can write 1 upon m and it should be equal to k upon m square plus 2k. So we can write this equation as m equals k plus 2k into m square. So it will be 2k m square minus m and then plus k equals to 0. Now it says two different tangents can be drawn. So that means this equation should have two real roots. That is, value of d should be greater than 0. So if we'll find d, it will be 1 minus 4 and it will be 2k square. It should be greater than 0. That is 8k square should be less than 1. So now in the question it says 8k square is less than alpha. So that means value of alpha is simply 1. Now here the question is, the tangent PT and the normal PN to parabola y square equals 4x at any point P on it meets the x-axis at points T and N. The locus of centroid of triangle PTN is a parabola whose vertex, directrix, latus, rectum and focus is which of the following, right? So we have this parabola which is y square equals 4x. And on that we have any point P which is AT square 2AT. Now at this point P we have drawn a tangent which meets x-axis at some point T, and then we have also drawn a normal to it at this point P which intersects x-axis at point N. Now since it is a locus problem, first thing is identify the points. We'll need to find locus of this centroid. So let this point be alpha comma beta. Now we know that equation of tangent at this point P is given by Ty equals x plus at square. We need to find its point of intersection with x-axis. So for x-axis we'll put y as 0. So we'll get x as minus at square. So this point T will be minus at square comma 0. Now equation of normal to this parabola will be y plus tx equals at cube plus 2at. Now again this point N, it lies on x-axis. Again we'll put y as 0. Now here we'll get x as at square plus 2a. So this point N will be at square plus 2a comma 0. Now we need to find centroid of this triangle. So this alpha will be at square minus at square plus at square plus 2a. So it will be at square plus 2a by 3, and then we'll also find beta. Now beta in this case will be 280 upon 3. So 280 upon 3. Now we can eliminate this t. So we can write this equation as 3 alpha equals a. Now in place of t we can write 3 beta upon 2a. So there will be 9 beta square upon 4a square plus 2a. Now here a and a, it will cancel. So we can write this equation as 9 beta square upon 4a, and this is equal to 3 alpha minus 2a. So we can rewrite this equation as beta square equals 4a by 3 and alpha minus 2a by 3. Now in the end we'll change beta with y and alpha with x. So this locus will be y square equals 4a by 3 and then x minus 2a by 3. Now we'll compare it with the standard equation which is y square equals 4a capital X. Now here value of a is a by 3 and capital X is x minus 2a by 3. Now the first thing is its vertex. Now vertex is at capital X equals 0 and capital Y equals 0. Capital X is x minus 2a by 3 and capital Y is same as small y. So it'll be at 2a by 3 comma 0. So that's your option number A. Second is focus. Now we know that for the first form focus is a comma 0. So capital X is a and capital Y is 0. So capital X is x minus 2a by 3 is equal to a by 3 and capital Y is small y. So it will be simply a comma 0. So focus is at a comma 0. Now what's latest rectum? Latest rectum is 4a. So 4a simply will be 4a by 3. So in this case option number C is incorrect, and now we need to find equation of directrix. So equation of directrix is capital X equals minus a. So it will be x minus 2a by 3 is equal to minus a by 3. So its equation will be x equals a by 3. So option B is incorrect. So the correct options are option A and D. Now here the question is, let A, R, S, T be non-zero real numbers. Let P, Q, R and S be distinct points on parabola y square equals 4ax such that PQ is a focal chord and lines QR and PK, they are parallel where K is a point 2a comma 0. First thing is we'll need to find value of R. So first we'll draw this parabola. Now it says PQ is a focal chord. So we'll draw this PQ. So this is P and this is Q. This is focus, which is a comma 0. It says P is at square 280, and we know that in case of a focal chord T1 into T2 is minus 1. So we can write coordinate of Q as a upon t square minus 2a upon t. Now it says we have another point r such that QR is parallel to PK. Now K is a point which is at 2a comma 0. So we have this line PK and it says a point R is on this parabola such that this QR is parallel to PK. So first we'll find slope of PK. Now slope of PK simply will be 2at upon at square minus 2a. So we'll cancel this a. So it will be 2t upon t square minus 2. And then we'll also find slope of QR. Now this r, it is given as AR square and 2AR. Now slope of QR, it will be 2AR minus minus plus 2A upon T divided by AR square minus A upon T square. So now here we'll cancel A. So we'll get 2 R plus 1 upon T. And here we'll get R square minus 1 upon T square. So it will be A plus B, A minus B. So it will be R plus 1 upon T and R minus 1 upon T. So we'll cancel. So we'll get this as 2 upon R minus 1 upon T. Now they are parallel. So we'll equate them. So we'll write 2T upon T square minus 2. It is equal to 2 upon R minus 1 upon T. Now this 2 will cancel. T into R minus 1, and this is T square minus 2. Value of R should be T square minus 1 upon T, and that's your option number D. Now the second question is, if S into T is 1, then the tangent at P and the normal at S to parabola meet at a point whose ordinate is. So now we'll write equation of tangent at point P. So equation of tangent at point P is given by Ty equals x plus at square, and equation of normal at any point S, it is y plus, now for S, its parameter is S. So it will be y plus S into x plus at cube plus 2at. So it will be a s cube plus 2as. Now it is given that S into T is 1. So we'll multiply it with T. So we'll write Ty. Now S into T is 1. So it will be Ty plus X. And here it will be A S square plus 2A. Now we'll need to find ordinate of this point of intersection. So we have to eliminate this X. So we'll add these two equations. So we'll add these two equations. X will cancel. So we'll write 2Ty. And this is at square plus as square plus 2a. Now here we'll take a common and we'll write s as 1 upon t. So we can write this as 2ty and this is a, and it will be t plus 1 upon t whole square. So its y coordinate will be a t square plus 1 whole square, and then it will be 2t cube, and that's your option number B. Now in this video, we'll need to find point of intersection of two normals. We know that equation of normal to a parabola, we can write it as y plus t1x equals a t1 cube plus 2at1, and we can write other equation of normal in terms of parameter say t2. So y plus t2x equals a t2 cube plus twice a t2. Now we'll subtract the second equation from first. We can write t1 minus t2x, and this is a. It is a cube minus b cube. A cube minus b cube will be a minus b, a square plus b square plus ab, and then plus 2a t1 minus t2. Now we'll cancel t1 minus t2. Now t1 and t2, they cannot be equal because in that case we'll have same equation. So we need two different equations. So its x coordinate will be a and t1 square plus t2 square plus t1 t2 plus 2, and if we'll put the value of x in this equation, and if we'll put the value of x in any one equation, we'll get the value of y. So y plus a will be t1 cube plus t1 t2 square t1 square t2 plus 2t1, and it is a t1 cube plus 2a t1. Now a t1 cube will cancel and 2a t1 will also cancel. We'll get this y coordinate as minus a, and then we'll take t1 t2 common and it'll be t1 plus t2. So point of intersection of two normals will be a t1 square plus t2 square plus t1 t2 plus 2 comma minus a t1 t2 and t1 plus t2. So that is the point of intersection of two normals of a parabola. Now here the question is, if minus 3 comma 2 is one end of focal chord PQ of parabola, y square plus 4x plus 4y equals 0, then slope of normal at Q is. So first we'll write this equation as y plus 2 whole square and then plus 4x minus 4 equals to 0. So it'll be y plus 2 whole square equals minus 4 and it'll be x minus 1. So we'll compare it with the standard form. It'll be capital Y square equals minus 4a capital X. Now for this parabola, parametric coordinates are minus 80 square minus 280. So we'll write x as minus 80 square and capital Y as minus 280. Now a in this case, it is 1. Y is y plus 2 and x is x minus 1. So we'll write x minus 1 as minus t square and y as y plus 2 equals minus 2t. So its parametric coordinate, say p, it will be 1 minus t square and minus 2 minus 2t. Now we'll compare it with this given point, which is minus 3 comma 2. Then from the first one we'll get 1 minus t square equals minus 3, value of t is plus or minus 2, and if we'll compare the second one, we'll get 2t equals minus 4, value of t is minus 2. So that means for this point p, the value of parameter t is minus 2. Now for endpoints of focal chord, we know that t1 into t2 is minus 1. So the other end of this focal chord will be simply minus 1 upon t, so which in this case is simply 1 by 2. Now what is slope of normal at Q? Slope of normal at any point Q is minus t dash, and there'll be minus 1 by 2. So answer to this question is simply option number 1. In this video, we'll be discussing shortest distance between the two curves. There'll be many problems in coordinate geometry where you'll be given two curves or maybe a point and a curve, and you're supposed to find shortest distance between the two curves. Say for example, the point on the parabola y equals x square plus 7x plus 2, which is closest to the line y equals 3x minus 3. So we need to find a point on this parabola which is closest to this line using conditions of normal. So this line of shortest distance will occur along a common normal. Now this shortest line will be perpendicular to this given line. So its slope will be minus 1 by 3. So we need a point on this parabola whose slope of normal is minus 1 by 3. So we'll differentiate this parabola. So if we'll differentiate, we'll get dy by dx as 2x plus 7. Now dy by dx, it should be 3 because normal is minus 1 by 3. So we'll get the value of x as minus 4 upon 2, and which is minus 2. And then if we'll put the value of x in this equation, we'll get the value of y. So we'll get it as 4 minus 14 plus 2. So it'll be minus 8. So here we can say the point which is at a shortest distance from this curve is -2, -8, and that's your option number 4. So this question, it is pretty simple when we do it using the concepts of normal rather than solving it using maxima and minima. Now let us take another question, which is P is a point on parabola y square equals 8x, which is at a minimum distance from the center of the circle x square plus y plus 6 square equals to 1. Then the equation of circle passing through C and having its center at P is. So we are given this circle whose center is at 0, -6. And whose radius is 1 unit. And then we have this parabola which is y square equals 8x. Center of this circle is C, and it also says we have a point P on this parabola which is at a minimum distance from center of this circle. So we know that minimum distance occur along common normal. So this line CP, it is normal to this parabola. Now for the first form, we can write equation of normal. So for the first form, equation of normal is y equals mx minus am cube. Now a in this case is 1, so it will be 2m cube minus 2am, so there will be 4m, and we need a normal which passes through this point 0, -6. We'll put y as -6 and we'll put x as 0, so it will be minus 2m cube minus 4m. So we'll get this equation as m cube plus 2m minus 3 equals to 0. So we can write this as m cube minus m plus 3, m minus 1 equals to 0. So we can take m minus 1 common, then it will be m square plus m plus 3 equals to 0. Here we are getting only one solution, and that is the value of m is equal to 1. So the normal which passes through center of the circle has a slope 1. Now once we have slope of normal, we know that this foot of normal is given by am square minus 2am. So am square, so a it's 2, so it will be 2 and then minus 2am. Minus 2am will be minus 4. So coordinate of this point P will be 2, minus 4. Now we need to find equation of circle passing through center C and having its center at P. So we'll find its radius. So its radius will be under root of, now 2 square it is 4, and then plus 2 square again will be 4. So it is 2 root 2. So now we have radius and center. We can write this equation. So equation of this circle will be x minus 2 square plus y plus 4 whole square equals 8. So it will be x square plus y square minus 4x plus 8y, and it will be 16 plus 4 20. 20 minus 8 is 12. Plus 12 equals to 0, and that's your option number C. X square plus y square minus 4x plus 8y plus 12 equals 0. Now here the question is, find the shortest distance between the parabolas y square equals 4x and y square equals 2x minus 6. So we know that shortest distance, it occurs along common normal. So first what we'll do is we'll find equation of common normal to these two parabolas. So for this first parabola, equation of normal will be y equals mx. Now a here is 1, so it will be minus m cube minus 2m. And for the second one, we can write this equation as y square equals 2, x minus 3. Now here the value of a is 1 by 2. So we can write this equation as y equals m. Now in place of x, we'll write x minus 3 minus am cube. So it will be 1 by 2 m cube minus 2am. So it will be minus m. Now these two equations, they represent the same line. So we'll compare their constant terms. So here we'll get minus m cube minus 2m, and this is minus 3m minus m cube by 2, and then minus m. So here it will be minus m cube plus m cube. So there will be m cube by 2 and then minus 2m equals to 0. So we'll get the value of m as either the value of m is 0 or the value of m is plus or minus 2. Now we can write foot of normal on these parabolas. So for this parabola, foot of normal is am square minus 2am, and for the second parabola it will be am square plus 3, because here we have x minus 3. So x minus 3 is equal to am square. So x equals am square plus 3 comma 2am. So now if we'll put m as 0, then we'll get 0 comma 0 and 3 comma 0. Distance between them is 3 units. If we'll take m as 2, then in that case, now for this one value of a is 1 and for this one value of a is 1 by 2. So if we'll put a as 1, so it'll be 4 comma minus 4, and point on the other parabola it will be 5 comma minus 2. So here distance between them will be under root of, so this is 1 and then plus 2 square, which is 4. So distance here is root 5, and if we'll take m as minus 2, we'll get this point as 4 comma 4, and here in this case it will be 5 comma plus 2. So again distance between them will be 1 plus 4, that is under root of 5. So the shortest distance between these two parabolas is under root 5. Now here the question is, find the minimum value of x1 minus x2 square plus 12 minus under root of 1 minus x1 square minus under root 4 x2 whole square. Now if we look at this formula closely enough, it looks like distance formula, which is x1 minus x2 square plus y1 minus y2 square. We can write y1 as 12 minus under root of 1 minus x1 square, and we can write y2 as under root of 4x2. So if we'll square it, we can write this as x1 square plus y1 minus 12 whole square is equal to 1, and here it will be y2 square equals 4x2. Now this first point, it lies on this circle, which is x square plus y minus 12 square equals 1, and second one, it lies on this parabola, which is y square equals 4x. Now we need to find minimum value of this expression, which actually is square of shortest distance between these two curves. So we need to find square of shortest distance between this circle and parabola. Now we know that shortest distance, it occur along common normal. So any normal to this circle, it'll pass through its center, which is 0, 12. And for this parabola, value of a is 1. Equation of normal for this parabola will be y equals mx minus am cube minus 2am. Now we need that normal of parabola which passes through 0, 12. So we'll put x as 0 and y as 12. So it'll be 12, and it is minus m cube minus 2m. So we can write this equation as m cube plus 2m and then plus 12 equals 0. If we'll put m as minus 2, we can write minus 8 minus 4 plus 12 equals to 0. So that means one of the root is minus 2, and we can use synthetic division. So this is minus 2 and it is 1, 0, 2 and 12. So it is 0, 1, minus 2. So it will be minus 2, 4, 6, minus 12, 0. So we can write this equation as m plus 2 and then m square minus 2m plus 6 equals to 0. Now for this equation, there is no real root. So the only value of m that we'll get here is minus 2. So the value of m is minus 2. Now once we have this m, we can write foot of normal. So let that point be P. So foot of normal is am square, so which is 4 and then minus 2am. So minus 2am will be simply 4. So the point on this parabola which is closest to this circle is 4, 4. So now we have this circle having center at 0, 12 and radius is 1, and then we have this parabola and the point which is closest to it is 4, 4. Now we need to find this shortest distance. So what we'll do is we'll find distance between center and this point P. So we'll find CP. So CP in this case will be 4 square plus, now this is 12, 12 minus 4, it is 8, 8 square is 64. 64 plus 16 is under root 80 and 80 is 4 root 5. So this is 4 root 5. So this distance CP, it is 4 root 5 and radius of this circle is 1. So the shortest distance which is D, so shortest distance between this circle and parabola will be 4 root 5 minus 1. Now in this question we need square of this minimum distance. So D square, it will be 4 root 5 minus 1 whole square, and that is the answer to this question. Now here the question is, find the minimum distance between the curves y square equals x minus 1 and x square equals y minus 1, and say the distance is D. We need to find the value of 2 root 2 into D. So first we have this parabola which is y square equals x minus 1. So parabola opening right and shift it to 1, 0. And then we have this parabola which is x square equals y minus 1. So parabola opening upwards, again shifted 1 units. Now we need to find minimum distance between these two curves. Now what we know is minimum distance, it occurs along a common normal. Now we need to find common normal between these two parabolas. But in this question, solving common normal wouldn't be that easy, because here we have this first form and third form, and this equation will be really complicated. But if we look at these two equations, y square equals x minus 1 and x square equals y minus 1, they're closely related. If we'll interchange x and y, then from first we'll get second equation, and from second we'll get first equation. So basically these two parabolas, they are inverse parabolas of each other. So basically they are reflection of each other about this y equals x line. So these two parabolas, they are reflection of each other about y equals x line. Now this line of common normal will also be perpendicular to this line, which is y equals x. So slope of this line is 1. So we need to find points on these curves, say A and B, whose slope of normal is simply minus 1. Now since the situation is symmetric about y equals x line, what we'll do is we'll find this distance, and then the shortest distance between these two parabolas will be double of it. Now for this parabola, y square equals x minus 1, we know that foot of normal, which in this case is B, will be given by, now since it is x minus 1, so it will be 1 plus am square. So 1 plus am square and then minus 2am. Now a in this case is 1 by 4 and the value of m is simply minus 1. So we can write the coordinate of this point B as 1 plus 1 by 4, comma, now it will be m minus minus plus will be 1 by 2. So coordinate of this point B, it will be 5 by 4, comma, 1 by 2. Now we can find this distance, which is d by 2. So this distance is perpendicular distance of this line x equals y from this point, which is 5 by 4, comma, 1 by 2. So this d by 2, it will be 5 by 4 minus 1 by 2 upon root 2. So it will be 3 upon 4 root 2. So we can write 2 root 2 into d. This value is equal to 3. So the answer to this question is the value of 2 root 2d is 3 units. Now in this video, we'll be discussing some important results in parabola. Now the first result is, if the tangent and normal at any point P of the parabola intersect the axis at T and G, then we need to show that ST equals SG equals SP. So what we'll do is, we'll draw this parabola. Suppose it is y square equals 4ax, and on this parabola we have a point P whose parameter is suppose t, at square 280, and focus it is at a comma 0. Now tangent drawn at point P intersect axis at T. So we'll draw tangent at P. So it will intersect x-axis at point T, and we'll draw normal to this parabola at this point P itself, which intersects axis at G. Now we need to show that ST is equal to SG, and it is equal to focal distance, which is SP. So at any point P, equation of tangent is given by Ty equals x plus at square. Now for x-axis, we'll put y as 0. So this point T will be minus at square comma 0. And we know that at any point P, equation of normal is y plus tx equals at cube plus 280. Now again for x-axis, we'll put y as 0. We'll get x as at square plus 2a. So coordinate of this point G will be at square plus 2a. Now we'll write this distance st. So this distance st is a plus at square. Now sp, it is focal distance, and we know that focal distance is a plus at square. And if we write sg, it is at square plus 2a minus a. So it will again be a plus at square. So from here we'll say st is equal to sp is equal to sg. Now the next part of the question says, if we'll consider directrix and we'll draw a perpendicular from this point P on directrix, then we know that this angle is equal to this angle because it is an isosceles triangle. Now these are parallel lines, so this angle is again same. So this angle is equal to the other angle. So from here we can say the tangent and normal at any point P on parabola are the bisectors of angle between focal radius SP and perpendicular from P on the directrix. That's our result A. Now we'll come to this result B, which is the portion of tangent to parabola cut off between the directrix and the curve subtends a right angle at focus. So that means this portion of tangent subtends between this point and directrix, it subtends right angle at focus. So we need to prove that this angle TSP is 90 degrees. Now we already have coordinate for P and we also have coordinate for S. We'll find coordinate of this point and say this point is R. So equation of tangent is Ty equals x plus at square. Now we need point of intersection with directrix, and which is x equals minus a. So we'll put x as minus a, we'll get y as at minus a upon t. So coordinate of this point R will be minus a and a, t minus 1 upon t. Now we'll find slope of SR. Now we have R, we have S, which is a comma 0, and we have P, which is at square 280. We need to prove that this angle is 90 degrees. So we'll find slope of SR. Now slope of SR will be 0 minus this. So it will be a, t minus 1 upon t, and then it will be a and minus a. So it will be 2a. So we can write minus t square minus 1 upon 2t. Now we'll find slope of PS. Slope of PS will be 280 upon at square minus 1, which is 2t upon t square minus 1. So we'll multiply them. We'll get msr into mps, and this value is minus 1. So basically product of slope is minus 1, which means this angle PSR is 90 degrees. Now we'll come to this third result, which is the tangents at extremities of focal chord intersect at right angle on the directrix. So this part we have already proved in one of the previous videos, so we'll skip this part. Now next it says, hence a circle on any focal chord's diameter touches the directrix. So what we'll do is, we'll draw this parabola. And on this parabola, we have a focal chord. And then we have a circle whose diameter is n points of focal chord. And we need to prove that this circle, it touches directrix of parabola. So we know that for focal chord, we can write these points A and B as AT square 2AT and B as A upon T square minus 2A upon T. Now we need to find equation of circle for which n points of diameters are A and B, and we know that equation of such circle is x minus x1 x minus x2 plus y minus y1 into y minus y2. So we can write this equation as x minus AT square into x minus A upon T square plus y minus 2AT y plus 2A upon T equals 0. So we'll write this equation as x square plus y square and then minus A T square plus 1 upon T square x plus 2A 1 upon T minus Ty, and here it will be plus A square and minus 4A square, so it will be minus 3A square equals 0. Now we need to prove that this circle touches directrix of parabola. So equation of directrix is x equals minus A. So we'll put x as minus A, we'll get A square plus y square plus A square T square plus 1 upon T square plus 2A 1 upon T minus T y, and this is minus 3A square equals to 0. We can write this as y square plus 2A 1 upon T minus T y, and here we'll get A square and then it'll be T square plus 1 upon T square minus 2. So it'll be 1 upon T minus T whole square equals to 0. Now for this quadratic equation, value of T is 0. So that means there is only one point of intersection, which simply means this line is a tangent to this given circle. So this circle, it touches directrix of parabola. Now we'll also need to prove that a circle on any focal radii of point P. So suppose we take a point P. So let this point be P now. AT square 2AT. If we draw a circle on this focal radius, we need to show that this circle, it touches tangent at vertex, which is y-axis. So we know that for this circle, n points of diameter are A, 0 and AT square 2AT. So equation of circle here will be x minus A, x minus AT square plus y minus 0, y minus 2AT is equal to 0. So we can write this equation as x square plus y square minus A 1 plus T square x minus 2ATY and plus A square T square equals to 0. Now for this circle, we need to show that this circle, it touches y-axis. So equation of y-axis is x equal to 0. So we'll put x as 0, we'll get y square minus 2aty plus at whole square equals to 0, which is y minus at whole square equals to 0, which again is a perfect square, and it simply means for this intersection also d0. So there is only one point of intersection. This y-axis is tangent to this given circle. Now we'll also need to prove that this circle, it intercepts a chord of length a under root 1 plus t square on a normal at point P. Now we draw a normal at this point P. Then we need to find length of this chord. What we have now is, we have equation of this circle, which is x square plus y square minus a 1 plus t square x minus 2aty plus a square t square equals 0. So for this circle, we can write center. So center of this circle will be a 1 plus t square by 2 and at. We can also write radius of this circle. Radius of this circle will be a square 1 plus t square whole square by 4 and then plus a square t square and minus a square t square. So it'll cancel. So radius of this circle will be a 1 plus t square by 2. Now what we'll do is, we'll write equation of normal at P. So equation of normal at P will be y plus tx equals at cube plus 2at. Now we'll find perpendicular distance of normal from center. So perpendicular distance from center, it will be at 1 plus t square by 2 plus at minus at cube minus 2at upon under root of 1 plus t square. So this is d. So we have this circle and we have this perpendicular distance d, and we also have radius. So we'll simplify it. We'll take at common. So we'll get at, and here it will be 1 plus t square by 2, and here it will be minus 1 plus t square upon under root of 1 plus t square. So this distance d, it will simply be at into under root of 1 plus t square by 2. Now we can write length of this chord. So this is L by 2. So we can write L by 2 is equal to under root of r square minus d square. So basically this length L will be 2 times and under root of r square. R square simply is a square 1 plus t square whole square upon 4 and then minus d square. D square is a square t square 1 plus t square upon 4. Now here we'll take a square and 1 plus t square common. So we'll take it common. We'll write 2a under root of 1 plus t square. We'll also take this 4 common, and then we'll get 1 plus t square minus t square. So basically a will also cancel. So length of this chord will be a into under root of 1 plus t square. And that is the result we need to prove. Now in this video, we'll discuss reflection property of parabola. Now reflection property of parabola says that if we have a tangent drawn at any point P, which is say t equals to 0, and a normal drawn at the same point P, say n equals to 0, then PT and PN, they are internal and external bisectors of angle SPM. So that means this tangent, it will bisect this angle SPM internally, and this normal, it will bisect this angle SPM externally. This is the property which we are going to use in reflection property of parabola. Now if we have any parabolic mirror, and we know that along the normal, this angle is same. So if there is any ray of light which is parallel to axis of parabola, it will reflect from the surface and it will pass through focus of this parabola. So we know that law of reflection is angle of incidence must be equal to angle of reflection. So that means any ray traveling parallel to axis of parabola will converge at focus of this parabola. And in the same way, if there is any ray which passes through focus, it will become parallel to axis of parabola. Now there will be some questions on this reflection property of parabola. Now here the question is, a ray of light is coming along the line y equals b from a positive direction of x-axis and strikes a concave mirror whose intersection with xy plane is a parabola y square equals 4ax. So basically we have a paraboloid, but we are talking about its intersection with xy plane, which is simply a parabola. So we'll draw this parabola. Equation of this parabola is y square equals 4ax. Now it says there is a beam of light coming from this line y equals b. So suppose this is the line from which light is entering this parabolic surface. And now its equation is y equals b. It says find the equation of the reflected ray and show that it passes through focus of parabola. Basically, reflection property clearly says that this reflected ray, it will pass through focus of parabola. But still in this case, we need to prove that it will pass through focus of parabola, and we'll also need to find equation of reflected ray. So this is angle I. So it will reflect at the same angle I. Now suppose this point is P. Now we can find coordinate of this point P. So this point P has y coordinate equals b. Now we'll put y as b, we'll get x as b square upon 4a. Now for this point P, we can also write its parameter. So we know that this P is 80 square 280. So we can write T as b upon 2a. Now at any point P, slope of normal is given by minus t. So this slope of normal is minus t, which is minus b upon 2a, and slope of this line is simply 0. Now we need to find slope of this line which makes same angle as that of this normal and incident ray. So we can write m plus b upon 2a. So m2 minus m1 upon 1 plus m1 m2. So it will be minus bm upon 2a, and it will be equal to m2 minus m1 upon 1 plus m1 m2. So it will be minus b upon 2a minus 0 upon 1. So we can write this equation as 2am plus b upon 2a minus bm, and this is equal to b upon 2a. Now we can take plus sign as well as minus sign. So we can write this as 2a upon m plus b upon 2a minus bm equals plus minus b upon 2a. So we'll take plus sign. Then we can write it as 4a square m plus 2ab, and this is 2ab minus b square m. Now 2ab will cancel, we'll get the value of m as 0. So m equals to 0 represents the equation of incident ray and not the reflected ray. So we'll have to take minus sign. Then we'll get this condition as 4a square m plus 2ab equals minus 2ab plus b square m. So we can write m as 4ab upon b square minus 4a square. So now we have slope of this reflected ray. Now we can write its equation also. So equation of reflected ray will be y minus y1. So y minus b equals m and then x minus x1, x minus b square upon 4a. So now we can simplify this condition. So we'll write this as b square minus 4a square y minus b cube plus 4a square b, and here 4a will cancel, we'll get b, and this is 4ax minus b square. So we can write this equation as 4abx. We'll take it on the right hand side. It'll be plus 4a square minus b square y. B cube will cancel, and minus 4a square b equals to 0. And that is the equation of reflected ray. Now we need to show that this reflected ray will pass through focus of this parabola. So we know that focus of this parabola is a comma 0. So we'll put the value of x as a and value of y as 0. So we'll put x as a and y as 0. Then we can write this as 4a square b plus 0 minus 4a square b, which is 0. So that means this line for any value of a and b will always pass through a comma 0, which is focus of this parabola. So any ray which is parallel to axis of this parabola will always pass through focus of the parabola. Now let us take another question, which is a ray of light is coming along a line y equals 2 from the positive direction of x-axis and strikes a concave mirror whose intersection with xy plane is a parabola y square equals 8x. Then we need to find equation of the reflected ray. So we have this parabola which is y square equals 8x, and then we have this incident ray which is coming along the line y equals 2. So we can find this point. For this point, y coordinate is 2. So we'll put y as 2. We'll get x as 1 by 2. So this point will be 1 by 2, comma 2. Now after reflection, it will pass through focus of parabola. So we know that focus of this parabola will be at a comma 0. So it will simply be 2 comma 0. We'll need to find equation of this line. So we'll find its slope. So its slope will be 2 upon 1 by 2 minus 2. So it will simply be minus 4 by 3. So we can write this equation as y minus 0 minus 4 by 3 x minus 2. So it will be 4x plus 3y minus 8 equals 0. And that's your option number C. Now the next question is a ray of light moving parallel to x-axis gets reflected from parabolic mirror whose equation is y square plus 10y minus 4x plus 17 equals 0. After reflection, the ray must pass through the point. So we know that any line which is parallel to x-axis, which actually is axis of this parabola, it should pass through focus of this parabola. So all we need to do is we need to find focus of this parabola. So we can write this equation as y square plus 10y minus 4x plus 17 equals 0. Now we'll complete its perfect square. So we'll add 25 and we'll subtract 25. So we'll write this equation as y plus 5 whole square and minus 4x minus 8 equals to 0. So equation of this parabola is y minus 5 whole square equals 4 x plus 2. For this parabola, we need to write its focus. So we know that focus is at a comma 0. So capital X equals a and capital Y equals 0. So x in this case is x plus 2, a is 1 and y is y plus 5 equals 0. So focus of this parabola will be minus 1 comma minus 5. So any ray which is parallel to axis of this parabola must pass through focus of this parabola, which is option number B. Now the third question is a ray of light is coming along the line x equals lambda and lambda is less than 0 from positive direction of y-axis and strikes a concave mirror, x square equals 4y minus 1. So it represents a parabola opening upwards and whose focus is at 0, 1. So we'll draw this parabola. So this is the equation of parabola, which is x square equals 4 y minus 1. Now a ray of light is coming along the line x equals lambda, where lambda is less than 0. So we have this light. So we have this ray of light which is parallel to axis of this parabola. It will pass through its focus and it says the ray reflected from it is x plus y equals 2. So equation of this line is x plus y equals 2. So what we'll do is, first we'll write focus of this parabola. So we know that this is third form of parabola, and for the third form focus is 0, a. So capital X equals 0 and capital Y equals a. Now x in this case is simply x and y is y minus 1 and a is 1. So this point it is 0, 2, and clearly reflected ray, it passes through focus because it satisfies this equation. Now any ray which passes through focus will again be parallel to axis of this parabola. So what we need to do is, we need to find this point of intersection. So we'll find point of intersection of this line, which is x plus y equals 2 with parabola, that is x square equals 4 y minus 1. Now we'll write y minus 1 as 1 minus x. So we'll replace y minus 1 with 1 minus x. We'll write this equation as x square, and this is 4 minus 4x. So it'll be x square plus 4x and plus 4 equals 8. So we'll write this equation as x plus 2 whole square equals 8. Value of x should be minus 2 plus minus 2 root 2. Now since we are talking about this line, and for this line x should be positive, so its equation will be x equals minus 2 plus 2 root 2, and that's your option number D. Now in this video we'll solve some questions using polar equations of conic sections. In one of the previous videos we have discussed polar equations of conic section. I'll provide the link to that video in the description below, and we have studied that polar equation of any general conic is given by r equals L upon 1 minus E cos theta, where r is focal radius, which is distance from focus, and theta is angle that it makes with the axis, and here L is semi-latus rectum, and which in the case of parabola will be 2a, and we also know eccentricity in the case of parabola is simply 1. Now using this polar equation, we'll prove that the sum of the reciprocals of the segments of any focal chord is constant. So suppose we have any general conic, it may be ellipse, hyperbola or parabola, and then we have a chord which passes through its focus. Now say this is R1 and it is R2. We need to show that the sum of reciprocals of segments of any focal chord. So that means we need to prove that 1 upon R1 plus 1 upon R2, it is constant. We know that equation of any general conic is R equals L upon 1 minus E cos theta. So if we'll take this angle as theta, we can write R1 as L upon 1 minus E cos theta, and we can rearrange it as 1 upon R1 equals 1 minus E cos theta upon L. Now we know that for this point value of R will be R2 and angle in this case will be theta plus pi. So we can write R2 as L upon 1 minus E cos pi plus theta. Now cos pi plus theta is minus cos theta. So we can write R2 as L upon 1 plus E cos theta, and we'll rearrange again. We'll write 1 upon R2 as 1 plus E cos theta upon L. Now we'll add these two equations. So we'll add them. We can write 1 upon R1 plus 1 upon R2. Now here E cos theta and E cos theta will cancel. We'll get 2 upon L, and we can write this as 2 R1 R2 upon R1 plus R2 is equal to L, which is semi-latus rectum. So if you'll recall the condition in parabola, that harmonic mean of segments of focal chord is equal to semi-latus rectum. So that result, it is not just true for parabola, it is true for any conic section for parabola, ellipse and hyperbola. Now we'll prove the second result, which is the sum of reciprocals of two perpendicular focal chords is constant. So now we have two perpendicular focal chords. So we have any conic section, and then we have two perpendicular focal chords. And say this is S. Now say this is P and P dash, and suppose it is Q and Q dash, and say this angle is theta. Now say this is R1, R2, and this is R3 and R4. Now we can write R1 as L upon 1 minus E cos theta, and for R2 we can write R2 as L upon, now for this one angle will be theta plus pi, so it will be 1 plus E cos theta. So we'll find this length PP dash. So PP dash is simply R1 plus R2. So it'll simply be L, we'll take common, and then we'll have this LCM, which is 1 minus E square cos square theta, and then we'll also have 2. So it'll simply be 2L upon 1 minus E square cos square theta. Now in the same way, we'll find this Q and Q dash. Now for this Q, we'll write R3 as L upon 1 minus E. Now what about this angle? Now this angle will be theta plus pi by 2. So cos pi by 2 plus theta is minus sin theta. So it will be 1 plus E sin theta, and R4 it will be L and 1 minus E sin theta. Now we'll add them, we'll get Q dash. So it'll be simply R3 plus R4. In this case, it'll be 2L upon 1 minus E square sin square theta. Now it says we need to find sum of reciprocals of two perpendicular focal chords. So we need to find 1 upon PP dash plus 1 upon Q dash. So 1 upon PP dash plus 1 upon Q dash, it will be 1 minus E square cos square theta upon 2L plus 1 minus E square sin square theta upon 2L. So it will be 2 minus, now sin square theta plus cos square theta will be 1. So it will be 2 minus E square upon 2L, and which again is independent of theta. So that means sum of reciprocals of two perpendicular focal chords is also constant. Now the question is, consider the region xy such that x is greater than or equal to 0 and y square is less than or equal to 4 minus x. So we have this region which lies inside of this parabola. Y square is less than 4 minus x and x is greater than or equal to 0. So that means this circle, it is in this region. Now we need to find this circle C having the largest radius which can be inscribed in this region. So let that circle be this circle C with center at h comma 0 and radius equals r. Now equation of this circle will be x minus h square plus y square and it will be equal to r square. Now we'll find point of intersection of this circle with this parabola, which is y square equals 4 minus x to establish this condition of tangency. So we'll put y square as 4 minus x, so it will be x square plus h square minus 2xh plus 4 minus x, it is equal to r square, or we can write x square minus 2h plus 1x plus h square minus r square plus 4 equals 0. Now for largest circle, it has to be tangent to this parabola, and if it is tangent to this parabola, then it should have only one point of intersection, that is the value of d, it must be 0. Now if we put d equals 0, we'll get 4h square plus 4h plus 1 minus 4h square plus 4r square minus 16 will be equal to 0. Now this 4h square will cancel, so we'll get 4r square will be equal to 15 minus 4h, or r square will be 15 by 4 minus h. So this r will be maximum when this h is minimum. Now what is the smallest possible value of h? Now we can consider this h till the point where this circle is big enough to touch this y-axis. So in that case, this h and r will be equal. So for this largest circle, this h, it must be equal to r. Now if you put h as r, we get 4r square plus 4r will be equal to 15. Now we'll add 1. So we'll get 2r plus 1 whole square will be 16, or 2r plus 1 equals 4. Value of r is 3 by 2. So radius of largest circle will be simply 3 by 2. So answer to this first part is 3 by 2. So basically h and r, they are equal to 3 by 2. We can write equation of this circle as x minus 3 by 2 square plus y square will be equal to 3 by 2 whole square. So it will be x square plus y square minus 3x will be equal to 0. Now we need to find point of intersection with this parabola, which is y square equals 4 minus x. Now we put y square as 4 minus x will be x square minus 4x plus 4 equals to 0. That is x minus 2 whole square equals to 0. And since they are both tangent, we are getting only one value of x. So here the value of alpha is simply 2. So value of alpha in this case is 2. So answer to this question is 3 by 2 and 2.